you know, if you miss something or whatever, you know, you don't have to scramble and write notes or whatever. You know, you can just go back. Okay, so what I want to do is I want to start off talking about random variables. Okay, and so it's important to know what a random variable is. It's one of the important concepts in this class. So we're going to say that a random variable is some quantity that is the result of a process. We can't know it in advance, but we can know how likely it is that different outcomes occur. Okay? So this is our definition of random variable. That's something that's testable on a midterm. It's a very, very important concept, okay? So last time we talked about discrete random variables. We said these are random variables that are going to count how many times something happens. Okay, we had two examples. We had the binomial, we had the Poisson. Okay? And we said the binomial, basically we have a fixed number of trials, we have a certain conditions that we're going to apply to that process, and it's going to count the number of successes. And a lot of times when you're in business, you're counting the number of times something bad happens, okay? Like the number of defective units, okay, in a batch. We had Poisson, and we said Poisson counted the number of rare events, things like accidents, births, deaths, stuff like that. So in business, these are things that are also pretty important. Okay, so now we're gonna switch gears. We're gonna talk about continuous random variables, and we're gonna say, in a general sense, they're usually the result of some sort of measurement, as opposed to counting something. And of course, that's very, very broad. Okay, so for example, it could be a physical measurement. It could be income, for example. Even though income technically is discrete, you're counting number of cents. There's so many categories. We think of it as continuous, okay? And there are a lot of different continuous distributions, but the one that stands out, the one that's super important, is the normal distribution. And we're not going to touch on it really this class, but next class we're going to talk about something called the central limit theorem. It's the most important fact in all of statistics, and it totally hinges on the normal distribution. People used to call it Gaussian. They don't so much anymore. Where the word normal comes from, no one really knows. A statistician 100 years ago started using the term, and he was pretty influential, and everyone followed. It doesn't mean that the rest are abnormal, okay? So like we said, it's going to be some sort of physical quantity, but a lot of times income, percentage return, almost anything in finance is going to be continuous, a lot of things. Okay. And what we're going to see next class, we're not going to talk about it now, but we're going to see that even when the distribution itself is not normal for a random variable, the normal distribution still applies. So this is a very deep and profound fact of statistics, and it's actually quite important. We're going to spend a lot of time on that. But we're not going to worry about that today. Okay, so what I want to do, so one of the things I mentioned before is I said, okay, there's a lot of different concepts, right? There are certain things we want to understand the logic behind what's going on. And computing probabilities is one of those instances. So we're going to make a little mind shift. We're going to think about probabilities in a different way. So you're going to have to kind of shift your thinking here. Oh, here, let me give you a hand out. We're on the second page, so you didn't miss much. Sure, no problem. Okay, so let's go back to what we did before with discrete, okay? So we said, we had this thing called a probability mass function. That's what we used last time for binomial and Poisson. And that probability mass function was able to tell us the probability that any specific value occurred. So if I flip a coin 8 times, I could actually compute the probability that I got 6 heads, right? Now, what I want to do is I want to look at a plot, and we're going to interpret this a little bit different now. So here's the probability mass function of a coin that I flipped 4 times. And I'm going to count the number of heads, okay? So we know the probability we get 0 heads is 1/4, 1 heads is a half, 2 heads is a fourth, right? And we said something. We said all those probabilities have to sum to what? Unity, right. But I'm going to make a little bit of a shift here, okay? I'm going to notice it a little bit differently. Notice that these widths down here are 1, okay? So not only is the height of this function, 1/4, but so is the area, okay? Because it's 1/4 times 1, so the area is 1/4. So what I'm going to say now is not only do the probabilities have to add up to 1, but the area under this entire function also has to be 1 too. So this is the paradigm shift, okay? We're going from probabilities now, we're thinking of them as areas. So what we're going to say now is we're going to introduce a new sort of concept. We're going to say that we're going to think of probabilities as areas now. We haven't done that up to this point. And it's not obvious why we want to do it for this case, but we're going to see when we go to continuous random variables, we have to think that way. Okay, so we're going to extend this idea. Does that make sense to everyone? Everyone's good with that? Okay. Let's see how it applies to continuous. So this is one of the ways in which continuous and discrete are going to be different, okay? So we're going to start off with a continuous random variable. First of all, we kind of have to know the interval that the variable can take its values on, okay? So we're going to have to specify what the interval is. And so, for example, like if you look at, this is just some examples, if you look at, the average yearly percent return on a stock, okay? These are all the returns, the average returns from 1979 to 1995. So these stocks basically, X takes on values from minus 2.5 to positive 2.5. Okay, for this data set, the percentage returns are in this interval. Notice something. I don't know how much you guys went through histograms, but notice what your eye should be doing. Do you see this curve right here? Okay. What we want to be doing is we want to be trying to approximate that histogram by some sort of smooth curve. Okay, so I'm really thinking that the data comes from a distribution that looks like this. And it happens that that's a normal distribution. Okay, so that's what we want to start thinking about. It looks like a discrete random variable, but it's not. It's important to understand that. These little bins, I got those artificially. Okay, I defined this little bin width, and then I counted the number in that bin. But those numbers, in principle, can go out to 6 decimal places or whatever, right? Okay, so this is not a discrete random variable. I know it looks like it is, but it isn't. Okay, I could look at other things, like, for example, if you look at blood pressures, this is actual data from 1,000 Swedish men, okay? And so again, it has some sort of range, okay? It goes from 50 to maybe 130. And again, what your eye wants to be doing is kind of looking at the curve that goes through that histogram. Okay? So far, there's nothing really earth-shattering here. This is the way we're going to think of, this is how we're going to look at continuous distributions. But now we want to look at how we're going to compute probabilities, okay? So what we're going to do is, we had a probability mass function for discrete random variables. Let me just write this on the board. We're going to kind of compare and contrast. So for discrete, we have this thing called a probability mass function. And for continuous, we're going to have what's called a probability density function. And so these are terms that you want to get to know because I'm going to use them a lot. Okay. So this is applying to a continuous distribution. And how we think about it is we think of it as that best fit curve that's going to go through the histogram. I'm thinking that I could collect a whole lot of data. If I collected enough data points, I start to get something that begins to approximate, okay, a smooth curve. And so you can actually, if you can't read off the board, I have it right here, probability density function, okay. Okay, so again, so far nothing really big. But here's the thing that's a little tricky. Okay, when we had a probability mass function, that height represented the actual probability. For a probability density function, it's not the probability. It's a measure of how likely the value is to occur, but it's not actually the probability. So what is it? Okay? So first we're going to start off with the same as the probability mass function. It makes perfect sense to believe that the probability under that whole curve has to be 1 for continuous. Okay? For a continuous distribution. So this is a fact. And the reason why it makes sense is it's something that goes over from discrete. It's true for discrete, so we're going to assume it's true for continuous. Okay? You don't have to really stretch your imagination very much. I could take a histogram, for example, and I could calculate the percentage of each of those values, right? I could just divide each of those heights by the total number of objects in that sample, and I would actually get percentages, okay? And all of those percentages would have to add up to 1. Okay? But this is where we're going to start from. And so now what we're going to start to do is we're going to start to think of probabilities as areas. So this is a new concept. Something that you may or may not have seen before. So how do we actually apply this, okay? So here's how we apply this. If I want to compute the probability that this random variable x is in the interval a to b, that's how I'm going to write this. This is our kind of shorthand code notation, okay? It's going to be the area under that curve from a to b. I'm going to find the interval ab, and I'm just going to look at the area under that curve. And that's going to be my probability. So this is the kind of the picture we want to have in mind. So whenever I ask you the probability that a random variable is in some interval, you're just going to find that interval, okay? Find the area under there, and that's going to be the probability. This is an important fact because when we work with normal distributions, it's very, very geometric. We always want to draw pictures, okay? So these things that you think are algebraic, now are going to become geometric. So if you're a spatial thinker, you know, that's in your favor, right? Okay. Now, let's back up a second. Notice that I said I can't compute the probability of a single value. Why? Suppose, for example, I ask you, what is the probability that capital X is equal to small a? That has to be 0. Because what's the interval? The interval's a to a, right? There's no area under that. That's a line. Okay? So the probability that I get one specific value is 0. And the reason why that makes sense, you might say, oh, that doesn't make any sense. It actually does when you think about it. Think about you're measuring someone's height. What is the probability that someone's 72 inches? Exactly 72 inches. Okay? Think about it. It's almost 0, right? Because I want to be 72.000000. You're not going to find that person. Okay? That's the rationale. So you might say, well, how am I going to get probabilities? So this is a huge shift in thinking. We think in terms of percentiles. When we're interested in asking a question, how likely is it to get a value? We automatically think in terms of percentiles. So that's how we're going to start thinking about probabilities with continuous distributions. So it's very different. We can't ask the probability that any one value occurs anymore. All we can do is talk about its percentile. Okay? So this is how we're going to think about how likely a value is to occur. We're going to compute its percentile. If something's in the first percentile, that's very unlikely, right? It means there's only 1% of the population less than that value. It's very unlikely to get that value, okay? So this is how we're going to start thinking about probabilities. And we can't talk about probabilities that single values occur anymore. So one of the nice things, there's actually a benefit of this. I know it's a little screwy because we'd like to be able to talk about this, okay? But there's actually an advantage. One advantage is that when we're working with these intervals, we don't have to care about whether the endpoints are included. Because a single point doesn't contribute anything to a probability. Okay, so there's actually some of the kind of advantages to this. Okay, so this is kind of a lot of new concepts. Thinking of probabilities as areas, and giving up the idea of talking about the probability of a value, but thinking about its percentile when we want to ask how likely it is to occur. How does that sit with everyone? Everyone's pretty good with those concepts? Everyone's cool with those concepts? They seem strange?
Just, we got to see it in action, see examples using it.
Okay. All right. Okay, so now we're going to start talking about the normal distribution. And again, like I said before, I'm going to cover about 60% of what's in the book. There's a lot of things in the book that aren't particularly relevant or aren't particularly useful to us. And here's what I want to do basically. There's 4 things I want to look at. First, we're going to ask, what is a normal distribution? Okay, you may have some ideas, but we're going to be kind of specific about that. And we're going to see that, it's defined by really 3 things. Its shape, the mean, and the standard deviation. Those are the 3 things that kind of tell us most of the stuff we need to know about a normal distribution. But we'll get into those in more detail. And then we want to talk about, and this is the main part of this section, how do we get percentiles? Okay, we want to be able to go from a data value to a percentile, and from a percentile to a data value. So we're going to spend a lot of time on this. Very important. And we're going to introduce some new concepts. So this is a kind of a little bit of a jump, okay? We're going to introduce this notion of a z-score. And it's going to tell us how far we are from the mean in units of standard deviation. And what we're going to see is we're going to see that the percentile of a data value depends entirely on the z-score. So the z-score is central to getting the percentile. Okay. And then I want to talk about what we're going to compute. We're going to use Excel for everything, pretty much, okay? Talk about the 2 different things we can do with normal distribution. We can go from a percentile to a data value, and that's one command in Excel, or we can go from a data value to a percentile. So we're always going one way or the other, okay? And last but not least, we're going to talk about when we can use the normal distribution, okay? And then we'll talk about some applications. So it turns out that the normal distribution, there's no nice criterion like we had for discrete. Like for binomials, said, okay, we have a fixed number of trials, 2 outcomes, probability of success is the same, right? They're independent. It's binomial. We don't have rules like that. So we actually have to test if a data set's normal. And it turns out that that's a little involved, actually. Okay, and then finally, we'll talk about some problems and some applications. So this is what we want to cover. So even though we're not doing anything in the book, it's still a lot, and I'm going to elaborate. We're going to spend a lot of time on Excel commands. Okay, so what is a normal distribution? Let's start off and look at that. So we're going to give a quasi definition. Okay, in reality, the book gives the probability density function. That's the actual definition, but it really doesn't add anything. Looking at the function is very ugly. It doesn't really add anything. And so we think of the normal random variable as being defined in terms of its properties. So here are the main properties. So I'm going to always use capital X for the random variable value. That's going to be standard, just like we did for binomial and Poisson. And the most important thing about a normal random variable is that it's characterized by 2 parameters, the mean and the standard deviation. Okay, so the mean or the average and the standard deviation. And so sometimes I'm going to use this little shorthand, okay? When I want to talk about when I want to say that X is distributed as a normal random variable with mean mu and standard deviation sigma, since I don't like writing this huge honking phrase, we use this little shorthand, okay? This is statistician secret code, all right? And so if you tell me that a random variable is normal, and you tell me its mean and a standard deviation, I know everything about it. Okay? I have it perfectly characterized and perfectly understood. But what we're interested in is we're interested in a lot of properties of the normal random variable. So if you look at the probability density curve, it has some very distinctive properties. So we're going to draw the probability density curve like this. That's f of x. Mu is the mean. That's at the bottom. And the first thing we notice is it goes from negative infinity to positive infinity. Okay? Now, there's something I want to mention real quick. You know, with discrete random variables, we talked about how they're models, right? So, you know, a Poisson is a model for counting the number of accidents. Notice something really interesting here. This goes across all the real numbers. Now, does anyone know an example of a normal distribution off the top of your head? Has anyone ever come across something that's normally distributed? I'll give you an example. I'll give you a hint. Bell-shaped curve. IQ, right? IQ has that bell-shaped curve. You probably have seen that. Now, ask yourself, is it now, and people model it as a normal random variable very, very successfully. But think about it. If it was actually really normal, could you have a negative IQ? I know sometimes it seems like you come across people that do have negative IQs, right? But it's not possible. So it's important to understand that models are never realities. They're always approximations. We're going to see why that's not a problem, okay? But it's always important to understand that this is not truth. This is just an approximation of the truth. Okay, so first, in principle, it takes on all values. And of course, there's some really nice properties. These are very important. It's bell-shaped. In other words, it kind of flutes out at the edges, okay? It's symmetric about the mean. Very important because it means that the mean and the median are the same. And they're also the same as the mode. One of the few distributions where they're all the same. Why is the mean equal to the median? Okay, if it's symmetric about the mean, right? What's true about these two halves here?
They're exactly the same.
Right. And what's the area under this entire curve again? Mm-hmm. Or 100%. Right? So this whole the area under this whole curve is the probability of the value somewhere. So this is really 100% or 1 under this curve. So these two are the same area. So if these two have to add up to 100% or 1, each of these are 50%, that has to be the median. Okay? So we're going to start thinking about this. Symmetry is extremely important with the normal distribution. Okay. Next, notice that even though we said this isn't the probability, it does give us an idea of how likely a value is to occur. So the further you go out from the mean, the less likely you are, right? That curve's going to 0. Okay? And I'm going to introduce one more thing that doesn't make sense right now. It will in a minute, but it's one of the most important ideas. It's that the probability that a value is going to occur, and I should really say the percentile, right? I shouldn't say probability, I should say percentile of a value, depends on how far it is from the mean in units of standard deviation. This is a really important fact, and I'm going to elaborate this on a lot, but this is a very major property of the normal distribution. Okay, so this is a lot in this one slide. Any questions? Anything that people aren't clear about? Everybody's good? Okay.
What, just real quick.
No problem.
Why is the mode also equal to those two?
Good question. Anyone know? What is the mode? We haven't actually talked about it. What is the mode?
The number that occurs in that.
It's the most likely value, okay? So you have to be a little careful because we can't actually talk about the probability that this one value is going to occur, right? But if I take a little sliver, okay, if I looked at each of these values and took a little sliver, okay, this would be the most likely area, right? Okay. Or if I did a histogram, for example, the value that had the most number of counts would be at that value there, okay? All right. Okay, so first we're going to talk about what the roles of the mean and the standard deviation are. And by the way, I'm going to use these symbols mu and sigma because the book does and because it's just how everyone talks, okay? So mu, mean, standard deviation, sigma s. And basically what happens is these two things determine the appearance, okay? The mean, whenever you have a symmetric distribution, the mean tells you where the center is, always, okay? So the mean tells us where that center is, And the standard deviation is always a measure of how wide that distribution is. So let me give you a little quiz. Here's 4 different distributions, and here's 4 different parameters that go with those distributions. And I want to match each of these up to the correct distribution. Anyone want to take a shot at this? Morgan, you want to try to match one of these guys up?
First off, is
Hold on. Okay.
I was going to say the 0 and the 2, the mean and standard deviation was 0 and 2 would be D.
Bingo. I would agree, right? Because this tells me where the center of the distribution is, right? This guy's the center, so cross him off. Okay, you want to take one, Keith?
Nope.
What's that?
Nope.
No. There's one that's easy. What's the easy one?
The one she just did.
There's another one that's easy too. I guarantee you.
The 2 and the 4 is B.
Right? Because this one being the means at 2 means it has to be to this side of 0, right? Process of elimination.
So why is it not skewed? And am I thinking, if the mean is 2 and it's greater than 0, why is it not skewed?
A normal distribution will never be skewed.
Okay.
It'll always be. So this mean is just telling us where the center is.
Okay.
So I didn't put it on here, but I didn't have to. Because there's only one distribution.
We're all basing that off the same line.
Exactly. Exactly. They're all on the same number line. Okay, Shelley, you want to try another one? So now we get to the hard ones, right? These two have to refer to this one. How do I tell which is which?
Say C is 5 because it's taller.
The -2 and 2 is D. Right?
No. This can't be because this one's at 0, right? And this one's at +2.
Oh.
Okay.
Never mind. Yeah.
So these two guys must correspond to these two. They have the same mean, right?
I'm going to say C is the -2 and the 5.
Okay.
No. It's A because there's more of a deviation. I'm thinking.
Okay, so tell me your reasoning. You're absolutely right. No, so what's the reasoning?
I'm just looking at 5 as a larger number, and there's a larger span on A.
Okay. Because the standard deviation is a measure of the width, right? So these guys have the same center. They don't differ, but this one's wider, right? And so this curve here is going to be wider. So this is A, this is C, D, and B. Okay?
So the lower the standard deviation, the thinner it is.
I'm sorry?
The smaller the standard deviation is, the thinner the curve is.
Bingo. Exactly. That's right. Measure width. So this tells us where the center is, and that tells us how wide it is.
And we'll never have a negative standard deviation, correct?
You can't, because that's right, because it's actually a width. It's actually a length. It can be 0. If all the values are the same, the standard deviation is 0. But it can never be negative. That's right. So if I give you one on a quiz or an exam with a negative standard deviation, you know, aha, he's trying to fool me, right? What's that?
So just give us 3 choices with a negative standard deviation. One of them again?
That would be nice, wouldn't it? Okay, so here's how we're going to sketch this. So now we're going to work at this a little bit. So we're going to say, okay, suppose I tell you the mean. Yeah, Ron.
How would you draw one with the standard deviation of 0?
It just looks like a line.
Would it just look like a line?
It's a single line. That's right.
Okay.
That's right. It means that there's no deviation of the points from the mean, and the only way that can happen is if they're all the same value. And so that's really uninteresting. We almost never work with data sets like that. Okay, very, very rare. Okay, so now we're going to say, okay, suppose we know the mean and the standard deviation. How can we sketch this out? We're going to spend a lot of time doing this. So what we're going to do is we're going to draw an x-axis. We're going to put mean at the mean at the origin. Usually we think of 0 as the origin, but we're going to put the mean at the origin now. And what we're going to do is we're going to step out in units of standard deviation. Okay? It's hard to overemphasize this phrase. Okay. Sigma literally acts like a unit of measurement. It's like the inch mark on a ruler. It's how we're going to measure distance for a standard deviation, for a normal distribution. Oops, going backwards. So we want to do something like this. we're basically going to go up 3 standard deviations. So this is my mean. This is the point that's 1 standard deviation below. Okay? 1 standard deviation above, right? This is 2 standard deviations below. The mean minus 2 standard deviations. Okay? 2 standard deviations above. 3 standard deviations below. 3 standard deviations above. And we never go beyond 3. You'll see why in a second. There's no reason to. Whenever you have a problem involving a normal distribution, the first thing you should do is make that sketch. That's where you start. I've been doing this 20-some years. When I do these problems, I make a sketch. It gets me my bearings, okay? It does more than that, actually, but... So that's how we want to start off.
Real quick, on the left, you see that says basically the mu, which is mean, -3, -2, -1. And I see that on the left, that's where it's placed on there. But on the right, it looks like it's saying that the standard deviation is 1, 2, and 3. And that usually said is like the width of everything.
I'm not following. Can you explain it to me again?
This, to me, I see is, this is -3, the mean. These should be all mean, correct? And then the standard deviation is this.
Well, what I'm doing is, so the standard deviation is the width. What I'm doing is I'm actually adding that width to the mean.
Right.
Okay. So let's just do an example, just real quick. Suppose, for example, I tell you that you have a normal random variable with a mean of 10 and a standard deviation of 2. Okay. So what I'm going to do first is I'm going to draw 10, right?
That's where the vertex is on the number line, basically?
Right, that's why I'm going to take my origin, basically. That's right. Usually it's 0, but here I'm going to think about this as my origin here. And I'm going to step out in units of standard deviation in 2. So I'm going to go 2 above, that's going to be 12, right? So that's my mu plus sigma.
Oh, okay, I see.
10 plus 2, okay? I just keep stepping out. So notice, this is really like a unit of measurement, okay? Then I just go out 2, right? And so what will go down here?
That would be the 8.
That's right.
It just, when looking down there, to me I read mean is -3, and then the standard deviation sign. But what it's saying is mean and then -3 standard deviation. That I just got it.
Right,
Look at
right.
like an equation, maybe?
Yes.
A mean plus sigma?
Right. Yeah, you think of it like this.
Okay.
Exactly. Pretty good. Yeah. And so it looks kind of abstract there, but here it makes perfect sense, okay? All right. So this is the general form.
So to draw the bell curve, would we be at 14 or would we be at...
Good question. Okay, I'm glad you asked. So what I'm going to do is, I'm going to draw this bell curve, and what should happen is the curve should basically taper off at 3 standard deviations. So here it should be basically 0. Okay. Then I'll make a peak here.
Oh, so we don't even... It's always at 3. We don't have to...
Right.
do
It's
it.
always,
No.
yeah. And you'll see why in a second. There's kind of a reason why, but we never go to more than 3 standard deviations. And the curve should basically be super close to 0. It's fluting down, really tapering.
Would there ever be a situation when you go more than 3?
Very, very rarely. Very rarely.
So standard deviation, see, when you say, like, the 2, to me, like, where you're out, where, like, the 4 and the 16 are, the 2 should be, like, at 8 and 12. You know what I'm saying? It's 2 away from the mean.
Mm-hmm. Yeah, these are, okay, so these are 1 standard deviation away, right? I subtracted 2 and I added 2, right? And then this is 2 away and 3 away. Is that answering your question?
I think what he's saying is...
Like, instead of C went to 16 and went like this, here's your mean. To me, it should be, like, skinny.
Because
you
you're
only
2.
went 2 spots right or left.
I'm not quite following. Run this by me again now.
To me, okay, 10, which is your mean now.
Mm-hmm.
For 2, to me, you just go, you know, that's 9, that's 11.
Mm-hmm.
2 and 2, it should be like that.
No, because so we're gonna talk about this in a second. Basically, the curve always goes out to 3 standard deviations.
And is just the 2 for the standard deviation, is that how many, because instead, if that was 1, are you doing 11, 12, 13?
Right.
And it's 2, it's 2, 3 is 3, 6, 9, as long as, okay.
Right. So this is a universal law. It says whatever the standard deviations, it can be 1, it can be 2, it can be pi, anything. I'm going to take that as my unit of measurement. Exactly. So it's a very general fact. Okay, so let's see why. Why are we doing all of this so mysteriously? Okay, so we're going to start talking about what's called the empirical rule. And that's going to segue into z-scores. And this is kind of the logic behind how we get these percentiles. Yeah, Brian.
Before I confuse myself,
No, that's
does it
fine.
have anything to do with empirical data?
No, not really. It's just, okay, empirical here means kind of like rule of thumb. Usually empirical means that it's derived from data observations, but it means more here like it's kind of like a rough rule of thumb. Yeah. Yeah, the name's a little misleading. Okay, what I'm going to do is I'm going to start off, I'm going to look at values that are 1 standard deviation from the mean. Okay, so if we go back to this drawing here, I'm looking at these values that are between 8 and 12, okay? And the empirical rule says it's always true that 68% of the values lie between 1 standard deviation from the mean.
2/3, essentially.
Roughly 2/3. Exactly.
And that's just a known fact.
That's a known fact. Yeah, it's actually it's a theoretical consequence of normal distribution if you get into mathematics. But this is always true, no matter if the standard deviation is 2 or 1 or whatever. It's always true. And we're going to keep stepping out in units of standard deviation, and we're going to look at the probabilities. So if I go out now 2 standard deviations from the mean, it turns out that it's 95% of the values. Okay? So if I go back there, I'm now looking at between 6 and 14. Okay, 95% of the values are going to lie. If I reach in a bag and randomly draw out one, it's a 95% chance it comes from there. And finally, we get out to 3 standard deviations. And basically, it's everybody. And that's why we never go past 3 standard deviations. Almost never. Because practically all of the values, only 0.3% of the values, lie outside. Okay? So this is the empirical rule. It tells you if you're 1 standard deviation away, 68% of the values, 2 standard deviations, 95% of the values lie within there, 99.7% of the values lie within 3 standard deviations. This is something I want you to remember. This is an important rule.
What's the difference? Like the difference between them? There's 68 to 95. What is that?
It's just the percent of value. So this is saying here, basically, like you just said, 2/3 of the values are in here. Okay, notice when I go out, there's a higher area, so there's a greater probability, right? So 95% of the values are here. And then finally, when you go out 3 standard deviations, practically all the values are within 3.
Yeah, I understand that. I was just, I guess, trying to visualize the actual like difference, like this minus this, 95 minus 68. Is there any like rhythm or reason?
We're gonna get to that. We're gonna get to that. That's right. Okay, so that's an interesting problem. So let's take a look. But any questions on the empirical rule? What it's saying first of all. Okay, this is fact. Always true. Any mean, any standard deviation. Okay, so this is important to understand. Doesn't matter what the mean, what the standard deviation. It's always true. And really, it's kind of useful because the key thing I want you to take away from this, besides the actual percentages, is it is telling us how likely a value is depends on how far it is from the mean in units of standard deviation. Okay? This is a fact that it's actually in a reddish color for a reason. It's an extremely important fact. And that's the only thing that determines the percentile and for a normal random variable. So notice what I've done here is I could actually rewrite that plot there like this. Well, here I just put the number of standard deviations. Okay? And we're going to talk about this is actually called the z-score. But I could actually write a normal distribution like that? Well, these are just units. That 1 stands for 1 unit of standard deviation from the mean, right? This is the point that's 1 standard deviation below the mean, and this is the mean. Okay? So we're looking at distance from the mean, but it's signed, right? These are negative values below the mean, positive values above. It's a very different way of looking at things, okay? I know this is not, we're not in Kansas anymore, okay? This isn't what you're normally thinking of. But this is the logic. This is the logic behind how the normal distribution works. So you have to get into this mindset. And so like I say, standard deviation is like a unit of length. The more standard deviations you are away, the less likely you are to occur. And we're going to look at a lot of problems to convince ourselves that we really understand that fact. So these 3 pieces of information are really important for normal distribution. Okay, let's actually look at some problems with the empirical rule. I'm not sure how easy this is going to be doing Excel down here, but okay. So let's suppose we have a Honda Accords, and let's assume the prices are normally distributed. The mean is $18,000. The standard deviation is 3,000. Okay, first thing I'm going to do, I'm going to draw my plot. And I'm going to leave off the thousands. Let's just use K for thousands, okay? So I'm going to say that the price X is normally distributed with a mean of 18,000 and standard deviation of 3. So let's go ahead and draw this.
You can see that really don't need on a light.
Yeah, is that a little too dark?
Yeah, thanks.
You okay? Okay, right, thanks. Okay, so there's my mean, 18. And I'm going to step out in units of 3, right? So 21, 15, 24, 27, and then finally 12 and 9. Okay. And now I'm going to draw my curve.
On our midterm, are you going to have us write it in that form, write things in that form, or at least recognize?
It's okay. You don't have to write it in that form, but you should be able to read it. Okay. Yeah. Okay. So that's what the distribution looks like. Now we want to answer some questions using the empirical rule. Now, one thing I want to emphasize is we're going to compute probabilities with Excel too, normally. So when I want you to use the empirical rule, I'll explicitly ask you. So use the empirical rule, and then you can't use Excel. Okay. Okay. So let's go ahead and think about the price of a randomly chosen Honda. Okay. We randomly pick one. What is the probability that it's less than 18,000? Okay. Now, here's the way you want to think about this. There's 2 things you want to bear in mind. 3 things. First of all, you want to remember that this is symmetric about the mean. Okay, so symmetry is important. So pieces of the curve that are the same distance away, they have the same areas. Second thing we want to remember is that the area under the whole curve is 100%. Under the whole curve. We said 1, that's a probability, right? Probability of 1 is 100%, okay? Next thing we want to do is when we're given these values, we want to find how many units of standard deviation those values are away from the mean, okay? So here's 18,000. How many standard deviations away from the mean is 18,000? None, right? It is the mean. And I want to know the percentile, right? I want to know the probability that it's less than that value. That's the percentile, right? So what would the percentile for 18,000 be for me?
50%.
Right, because this whole thing has to have to 100%. Symmetry tells me that these 2 are the same, right? So each of those must be 50%. Good. So that's going to be 50%. So that one's easy. That's like a softball. You hope you see that one, right? Okay. So what's the probability that it's less than 21,000? So now this isn't quite as easy. So let's start off from the beginning. How many standard deviations is 21 from the mean?
1.
1, right? It's 3 and it's 1 standard deviation, right? Now, I want the probability that it's less than 21. So I want all of this area right here, right? Okay, that's the probability it's less than. Yeah.
So, would you first take that first thing that we just looked at, the 68%, and then since 18 to 21 is half of that 68%, we take half of that, what's that, 34?
Right.
And then we do 34 plus 50, and that'd be the percentage.
Bingo. Do you want to come and explain it? Here,
Do
go
I want to
ahead.
explain it?
Yeah, go ahead. Go ahead. Go ahead. That's
All
perfect.
right.
Go ahead.
All
That's
right.
really good.
Okay,
Give me a rest.
So like we just said, with the first ones here, this area, that's 68%, right? So if we take this and this, that's half of 68, that's 34, and then this is 50.
That's right.
34 plus 50 would be B. So, and that's 84.
Bingo. Because Morgan told me that lower half was 50, and we figured out that little half was 34. Excellent. Very good. Thanks. Okay. So, see, symmetry. We want to think of this as a puzzle. The whole puzzle has to add up to 100%. When you look at a value, how many standard deviations? Then he used the fact that, okay, this is 1 standard deviation away. What do I know about 1 standard deviation? I know this is 68. Then symmetry takes over. Okay? Because what I really want is this half. I know this half of the puzzle is 50. I want this half. It's half of the 68. That's the 34. It's just like putting together a puzzle. Cool. Now, there are other ways of doing this. How else could I have done this? There's actually another way I could have done this.
99.7.
Well, notice that, you think of a glass half full or half glass empty, right? So he looked at this half. But I could have looked at what was in the wings, right? I could have said if this was 68, this has to be 32. Okay? So if this is 68 here in the center, these two pieces have to add up to 32. Symmetry, each of those is 16, right? So this part here is 16. And this is what I want. That has to be 84. So there's more than one way to count a skin, right?
Even though it's not a full 100%? Or
But
99.7?
But this would add up to 100%, right? Because think about what I'm doing. I'm saying this is 68, right? Let me go ahead and show you this in. So this part's 68, right? So these are the two parts that are left, the wings. This has to be 38, right? Because 68, I'm sorry, this has to be 32, right? Everything has to add up to 100%. So if this is 68, this is 32. And by symmetry, each of these have to be 16, right? 32 divided by 2. So this little piece here has to be 16. And then I want everything below that little piece. I would do it the way Braun did it.
Yeah, that's how I did it.
But, different strokes for different folks. However, if you get to the finish line, it really doesn't matter, right? There's all different ways of doing this. Okay, good. So what's the probability that we're more than 24,000? Well, this is the same sort of problem, right? So the first thing I'm going to do is I'm going to think about what area I'm looking for, right? So I want the probability that I'm more than 24,000, okay? So I want this area right here, right? So how will I find that?
Is it negative 2.5%?
It is.
Okay.
And how did you arrive at that?
Well, I expected you to do the less thing, again, the 50 plus, and then the second quartile is the 95.
Right.
Divided by the 2.
So, right, so what Taylor's saying is, okay, this is 2 standard deviations away from the mean. What do I know about 2 standard deviations? I know that 2 standard deviations have 95% of the values, right? So that means that what's in these tails here has to be 5%, right? If this whole thing has to be 95%, these two have to add up to 5%. Exactly. And symmetry takes over, and this is 2.5%. Okay? So you always start out, how many standard deviations away? What do I know? And then you use symmetry. Same old thing. You guys want to see one more?
Of course.
Sure. Okay.
Oh,
Okay, so this one's a little bit different actually. So this one's a little actually, he doesn't think this one we can already do, but that's okay. Let's go ahead and do it. This wasn't the hard one.
yeah. Is it just 95 divided by 2?
Exactly, 95 divided by 2, right? Because what is this value? It's 2 standard deviations away. What do I know about 2 standard deviations? This whole thing's 95. I want half of that, so this is going to be half of that, which is 47.5%. Okay. Just like putting together a puzzle. All right, last one. I think this is the curveball. Here you go, 15 and 24. Okay. Okay, so let's look at these two. So 15 is how many standard deviations away? 1, right? 24 is 2 standard deviations away. And I want this guy right here.
Is it 47.5 plus 34?
That's it, exactly. That's right. Because this has to be 95%, but this is half of this part of the puzzle. So that's 47.5. And I know this is 68. I want half of that, 34. And so you add these up, you're going to get 91.5. Good. So usually it's easier to work with the interior pieces because that's what the empirical rule tells you. Some people like doing the tails. I find that harder myself. I find that more difficult to do. Okay. Any questions on the empirical rule? I think we've all pretty much mastered it.
Costs
Very last one.
27K.
I'm sorry?
Costs more than 27K.
Okay, we'll do one more. Although I think you guys pretty much have this down now. Okay. Okay, then you want to... I'll tell you, Phil, I haven't heard from you. Help us out with this one.
Could be 2.5, correct?
Okay, so let's start at the beginning. How many units of standard deviation from the mean is 27?
I think it'd be 0.3.
It'd be 0.3 divided by 2.
Do you agree? What's that? She said 0.3 divided by 2. Does that sound right?
No. Just 0.3 because it's greater than just that one number.
Yeah, but then you still have the other part over here.
Yeah,
That's not in the 99.7%.
So Reed, come on up and show us. Tell us. Show us. Yeah, show us.
Yeah.
You're right, by the way.
I am right?
You are right. So go ahead. You're okay.
Okay, so this is 3 standard deviations away, and that's 3. So all of it's 99.7. So you still have 0.3 on each side. So you just take the 0.3 and divide it by 2, and that's your answer. I didn't do the math, so I don't know what the actual answer is, but...
Just 0.5.
0.15.
0.15 exactly. It's just 0.3 divided by 2, and that's just going to be 0.15%. Okay. So very, very few people, not even 1%. Sometimes when you used to hear people talk about standard deviation, and they want to talk about someone that's very intelligent, they say he's 3 standard deviations above the mean, which means that he's in the 0.15th percentile. There's less than 1% of the people that are more intelligent than that individual. Okay, you'll hear people say that sometimes. Everyone's pretty good on empirical rule, it looks like. Okay, so I left some blank pages that you could work those out, but I think everyone has those pretty well. Let me see. Okay, so what I want to do now is I'm going to talk about something. I'm not going to dwell on this a lot, but I want to talk about something called the standard normal distribution. One of the nice things about the normal distribution is it lets us compare two things that are not the same on the surface. And let me give you a really simple example. Suppose, for example, when you graduate, you have two different job offers. Okay, you get a job offer in New York City for $75,000, and you get a job offer in Muncie for $59,000. Now, putting aside food, culture, entertainment, all that stuff, okay, thinking purely in terms of money, what's the better place to live?
Muncie.
Probably why?
Because you get more for your money. Everything's more expensive in New York.
Right. These two salaries are not the same, right?
Inflation.
That's right. Cost of living here is a lot higher. So we don't know yet, but there's a good chance Muncie's going to come out ahead because we know cost of living in New York City is probably more than 2 times, okay, Muncie. But let's suppose, being a good statistics student you are, you do your research, you find out salaries are normally distributed, and so basically, if we think about this for a second, what we want to find out is the key thing is what income puts us in the higher percentile, right? If I'm in the 99th percentile in Muncie, that means only 1% of the people have more money. I'm living really well, right? If I'm in the 70th percentile here, I can't buy as much, right? So it's the percentile that's really important here. It's what we want to focus on. We want to find out what salary is in the higher percentile. And let's suppose we find out this is normally distributed. The mean is 60, standard deviation is 10, and the mean here is 45, standard deviation is 5. Let's go ahead and sketch this out, okay? So this looks like this. Okay. My mean's at 60. I'm going to step out in units of 10. And Muncie looks like this. Okay. And let's look at our salaries, where they lie, okay? So New York City's here, and Muncie's, and you can't see it because the little symbol's covering it up, it's way at the end, right? I think I can get this guy to move. Now, which one do you think's in the higher percentile now? Muncie, right? And there's a way that we can kind of quantify that. We're interested in how many standard deviations we are away. So we're going to compute this thing called a z-score. So this is how many, so what the z-score represents, this is important. It's how many standard deviations you are from the mean. Okay?
So that's no matter what the number you put in. Like, so let's say his salary was like 57.3, then we can find how many units of standard deviation he is from the mean.
Exactly. It's the distance from the mean in units of standard deviation, because this is how we're measuring things. So this is 1.5 standard deviations above the mean. When I'm above the mean, z is going to be positive, right? When I'm below the mean, it's going to be negative. So I'm 1.5 standard deviations above. But notice where I am in Muncie. I'm a lot higher, right? If you actually do the calculations, here it's 59 minus the mean, 45, divided by the standard deviation. I'm 2.8 standard deviations. So these two things now are comparable, okay? When I compute the z-score, they're basically now, I can compare these two. Okay, this is, I can actually compute how much this is. I can't use the empirical rule, right? It's not a nice number, a nice even number. But we're going to see that we can compute this. But we know, even without doing the computations, this is further away in units of standard deviation, so it's less likely to occur. And I'm going to leave it for you as an exercise to show one of the really nice benefits of the empirical rule is that you can approximate the answer. Notice, I don't know exactly what this answer is, but I do know from the empirical rule what it's between. I know it's between 84 and 91.5. We did this calculation over here. Okay. This was when I was 1 standard deviation away, and this was when I was 2 standard deviations away. That's the percentile. So I know the real answer is between here. That's useful, because when you do your Excel calculations, this is a nice way of checking yourself, just to make sure you have the right answer. Okay?
So the z-score, it just tells us that this is 1.5 standard deviations away from the mean?
Exactly. That's it exactly. Perfect.
So if we didn't do the graph and we just figured out the z-score, what would tell us the answer? Would that tell us the answer, or do we need the graph to tell us the answer?
No, the z-score itself will tell you. But the graph is good to do, because everything kind of goes together, okay? When I make this graph, I can kind of see where everything is. But the z-score alone will tell you.
So Muncie was the better offer because
It's further away, so it's going to be in a higher percentile.
even though the z-score is greater than... I don't understand why the z-score...
Okay.
It's just better because the z-score is higher, right?
Right.
Do you want a higher z-score?
Yes.
Okay. So let's kind of break this down. Suppose we had a simple problem. Suppose we had these two salaries. Okay. What's the z-score for that guy there? How many standard? It's just how many standard deviations he is, right? Z is 1, right? And this percentile is the 84th percentile. That's what you guys told me, right?
So is the z-score and the standard deviation, it's not the same thing. So how can we say that the z-score is 1?
Because this is what the z-score tells us is this kind of like an instruction. It's telling you how many standard deviations to go from the mean. So when I tell you that the z-score is 1, that's like instructions. It's saying go 1 standard deviation from the mean. That's what this means. So if we actually compute this, it's the data value minus the mean. This would be 3, right? Divided by the standard deviation. Okay? So it's just telling us how many standard deviations we are away. What would be the z-score for that guy there? How many standard deviations is he?
2.
2. That's it. That's all there is to it, right? So his z-score would be 2. Okay, notice as I'm going in this direction, the area under the curve is increasing, right? The area to this side is definitely getting larger, right? As I'm going like this, the area to the left, which is the percentile, right? It's getting bigger and bigger.
Yeah.
Okay? So this score is definitely going to be the better one. It's going to have the higher percentile. Make sense? No?
Yeah.
Okay. So the z, and this is a hard thing to understand. It's really important. The z-score is just telling us how many standard deviations. It's just telling us a number of standard deviations. So this guy we can see, he's basically 1.5 standard deviations, right? Because this is 1 standard deviation, right? 2. And that's where we're getting the z-score from. Okay. So we know the answer already. We know that this one's better. But how much better? I mean, for example, if New York City is 90% and Muncie's only 95%, we might not really care, right? We might say, hey, let's go for the better, the better food and entertainment, right? Okay. But this is the idea. The larger the size of the z-score is, it can be negative or positive, but the more extreme it becomes, okay, that percentile becomes less and less likely.
Is there outliers? Like in our z-scores from before?
We'll never have outliers for normal distribution. Yeah. We won't have to worry about that. This is all kind of theoretical. The outliers really kind of pertain to data, but here we're looking at everything theoretically for the time being. Okay. Any other questions on this? Because z-score is really an important concept. Okay. And so we know this percentile. We know that's between that. You can actually work that out. That's a really good exercise to convince yourself that you believe that. And let's do some computations, okay? So I'm going to try to do this down here. Let's go into Excel now, okay? Open up Excel. Let's see how I'm going to do this. Okay. And so SAT scores, one of the times this is actually used is when people want to compare SAT and ACT scores. Okay, those are two things that are totally different, right? No matter how high an ACT score is, you'll never beat an SAT score, okay? But yet they're both normally distributed. So one of the homework problems I'm going to give you is like this income problem, where it is actually, income's usually not normally distributed. That's kind of fake, the one I made up. But ACT and SAT are. So you can compare two people. If a person has an ACT of 22 in math and a 720, another person has 720 in math, now you can actually compare them, okay? Even though they're apples and oranges. Okay, so let's go ahead and make a little Excel file. So we said the mean's 515. I'm going to bring this up because I can't see everything at the same time on here. Here we go. Okay, so we'll make a little thing here. We'll put mu, or mean if you want. Standard deviation, sigma, and the mean's 515. The standard deviation is 114. These are real numbers, by the way. And now I just want to compute the z-score for a bunch of different test scores, okay? So I'm going to put x here, and I'm going to put z here. And let me blow this up a little bit. Okay, so let's go ahead and put the x scores. We got 760, 400, 212. 760, 400, 212, and 550. And I want to compute the z-score here. So what I'm going to do is I'm going to say equals. And how should I do that here? What should I do to do this? What do you think, Taylor? How should I compute this z-score for this guy here?
I was playing catch up, so
That's okay.
I'm here now.
All right.
760 minus 515
Right.
divided by 114.
Bingo, that's it. It's the distance from the mean in units of standard deviation. Perfect. Okay.
So there's no actual formula in Excel, it's just plugging it in.
You know what? I think there is actually, but I want you to do this first because it's such an important concept. I think there is something called standardized, but we're going to pretend we don't know about that. There's one other thing I want to do. I want to repeat this calculation, right?
Oh, yeah.
So Shelley, what am I going to do?
Oh, I don't remember how you do it.
Well, what's the concept? What is it that I'm trying to do? I want to pull this down, right, and have it do all these guys, but I got to be aware because when I pull this down, that'll get pulled down also, right? So what do we use? Anyone remember?
It's the dollar sign, but I'm not sure on which one.
Exactly. It's the anchors. It's the dollar signs. That's right. So I'm going to put a dollar sign on both sides of the letter.
How do you know which one?
B1 and B2.
Exactly. Good question. What do I want to anchor here?
B1 and B2.
Exactly. I want these to be the same for all the calculations, right? I'm going to be subtracting off the same mean, divided by the same standard deviation. So I'm going to put a dollar sign on both of those B's, on both sides. I screwed up something. What the heck did I do? Here we go. Whoops. Come on. And you can work up here in the toolbar. It's a little easier sometimes. You have to excuse me. It's hard to work from here because I'm in a weird position. Okay, let's see if I can get this to work out. There we go. Once we do it for one, then it'll be easy sledding, right?
There's a knob on that chair so you can bring it up.
Oh. Thanks.
Not that one. It's the lever.
There's a
out
lever
to the left.
left hand side.
I'm sorry?
There's a lever
It's
on
on the
your
left
left.
hand side.
Spin the chair.
Oh, gotcha. Thanks.
Pull it up.
Yeah, let me just... Yeah, that's a little better, thanks. Okay, so now I can click on that, and now I can just put my little cursor and drag that, right? And I'm going to format this so it's just to a decimal place or two. Okay. All right. So those are my z-scores. Everyone's good with that? Everyone's getting that? Now notice I can tell, Caitlin said, do I have to draw the picture? I don't have to draw the picture. I already know what the unlikely values are, right? This is really far to the left. So this is going to be in a really small percentile, right? This is the furthest to the right. So this is going to be the largest percentile. So this is the smallest percentile, next smallest, next largest if you want, and the largest percentile. As z is increasing, the percentile is increasing, right? So you see, this is the logic of the normal distribution. This is how it works. Okay. All right, let's do a little bit more, and then we'll break. Okay. Now hold on to that. Don't save that. We're going to come back to this. Okay. I promise I'll get this fixed up next time. Sorry. Let's see. Oh, come on. Here we go. Okay. So now we know how to compute z-scores. Okay, so what I want to do, let's just start talking about how to do a computation. So go back to the Excel file. And anywhere, you can open up a new sheet actually, if you want. Type in the words norm for normal. Like binomial was binom, Poisson was, right, P-O-I-S. You type in norm, you see a whole bunch of things come up, right? Now, we're only interested in the first two. And remember Braun asked this question, I think, last class about older versions, okay? So some of these are for older versions. I think the .s is the older. We're not going to mess with that, okay? No one has that. No one has that. We're only interested in these two, norm.dist and norm.inf. And so let's talk about what we can do, and then we'll take a break, okay? It turns out there's two things we're going to do. Only two things. Makes it very easy. The first thing we're interested in is going from a data value to a percentile. Big surprise, right? That's what we've been doing all night. Data value to a percentile. So we have to be given 3 pieces of information. Well, 4 actually. First you have to be told that it's normal. Okay? Then you need to actually know the value of x. This is a data value, right? And then I have to give you the mean and standard deviation. And now I can figure out the actual percentile. Excel doesn't require us to use the empirical rule. We can figure out for any z-score what the percentile is, okay? And the way it does that, it has this cool command called norm.dist. And basically the way it works is, again, I can't emphasize enough, Excel's so cool, it actually tells you what to put in. So it tells you first put in the value of x. It's already assuming it's normal, okay? 4 pieces of information. This is the normal. Value of x. It says tell me what the mean is. Tell me what the standard deviation is. And cumulative is asking for percentile. So you think of this as, do I want the percentile or do I not want the percentile? That's what this always means. This is the question here. And the answer is we always want the percentile for normal. For discrete, we were able to say no. We could actually compute the probability of a point. But here we want the percentile, so we're going to say true. Okay? So that's the first guy. From a data value to a percentile. Dist data value. Okay? I used to always forget this. Now I've done it enough, I guess I remember. But dist is data value. DD.
So, are we computing the z-score with that, or is this just...
Well, here's the thing. Notice the empirical rule is cool, but it doesn't tell us anything if we don't have a nice number of standard deviations, right? Like it tells us if you're 1 standard deviation away, if you're 2 standard deviations away, but for that case of 1.5, it doesn't help me, right? So Excel tells you for any z-score, basically what it does is it computes the z-score, and then it figures out the area for that z-score, that percentile. Okay?
Oh, so it's telling us. Okay, gotcha.
So it lets us do it for any.
So
any
it just takes what we did in Excel a step further.
Exactly. That's right. It basically generalizes the empirical rule. So it's x, mu, sigma, true. We always want the percentile. And of course, sometimes we want to go the other way. We want to go from the percentile to the data value. And so now we use this thing called norm.inv. So we have to be given that it's a normal distribution. Instead of the data value, we're given the percentile. Again, I need the mean and standard deviation. And it's going to tell us what data value has that percentile. Okay? And that's norm.inv. Okay? It has a simpler form. All you do is you type in the percentile, the mean, and the standard deviation. There's no true or false. Okay? So it's nice. It's a simpler command. Probability means percentile here. Has to be in decimal form. Okay? Remember, when we're doing math, we always think of probabilities in terms of decimals, right? Okay. So I'm going to put the percentile in decimal form, then the mean, then the standard deviation, and it'll tell me what data value has that percentile. Okay. All right. Why don't we take a break here? This is a good time to take a break. We'll take a 10-minute break. Come back here around 7:30. Is that good? All right. Sounds good.
Where do we get probability from?
This is going to tell us. That's going to be the percentile.
Okay.
But it's going to be in decimal form.
So whatever we got from that first answer, we plug in there.
I'll tell you what. We'll do some examples. All will become clear after break. Go ahead and take a break, clear your mind, and we'll come back and we'll do a whole lot of problems. Okay. If anyone has any questions about anything from the changes, let me know, and be more than happy to discuss it with you. I don't think it'll be that bad.
When are you going to put some information on projects?
Yeah, probably like around the time that we do the midterm.
Okay.
Then we'll start. But if you have ideas or whatever, feel free to talk to me. You can't start too early.
Yeah, that's because I wanted to do like kind of my own personal ranking of the game I play, and just wanted to know how I would do that or how I would begin that. You know what I mean? It seems a rather daunting task. Some people, like groups of people, they'll do it on like forums, and they'll take information from across the country, and I'd be just doing it with my friends, you know. So, I guess I was just wondering what the project would be or pertain, what I would need to accomplish that.
So what do you want to do? What's the basic idea?
Well, it's a typical fighting game. Okay, well, not typical at all, but it's a rather unique fighting game, and I wanted to see if I can, among the people I play with, find the best character to play in a certain stage, just one specific stage, and I guess I just want to see how I would quantify that, and
so you have, like, hypothetically, we'll just say, like, how many people do you have in this group?
Well, we have about four people in the group,
Okay.
but we have, I want to do among, I think, 5 characters, and only on one stage, though, so
Okay.
I'd have to maybe give you some background information on the game itself, but
Sure.
it's just, I guess I'm thinking, if I did it a certain way, it would take years, and if I did it another way, I'd be done in 5 minutes, you know what I mean? So I want to have like a good balance of how much data I would need to produce a a model of who would do the best on this stage and who wouldn't, that sort of thing.
Yeah, people do this a lot. I mean, people are like with it's a slightly different problem, but like with the fantasy, the fantasy sports league.
Yeah.
People do tons of stuff, and there are actually companies that people hire to do the fantasy sports league.
Really?
Like professional companies that they do other stuff, but they do a lot of this stuff. So yeah, I actually work at rankings. I do something a little bit different, but it's something that people think about a lot, and it's very useful. I mean, everywhere you go, everyone wants to know where they're at in business. So it's kind of useful. And you can think of this as kind of like, a lot of people think of business as like what they sometimes call game theory in a sense. So strategies, with different strategies and game theory. So you kind of look at it from a kind of game theoretic point of view.
My work.
So we'll probably hit, I can think of something, without knowing a lot about what you're doing.
Yeah.
Probably.
I'll just, maybe one of these days after class, I'll just give you some background on the game itself, see how it works. Because honestly, the way that they call it the back room of the game, it's like a group of individuals that are
Stressed out about my class.
I'm stressed out about it too. Shit. God.
What they say about the project, anything? All right, Phil.
He doesn't listen, but I guarantee he has the best grade this entire class. I don't either.
You already know how
Well, I
to do all
zone
this?
out when I actually zone in, everyone else is zone out. Up until like this test, I'm just like, I've been here for 9 weeks.
We know nothing.
And he's finally, paying attention, and then we
You go
stop.
home and you bitch, like, see like your friends or your roommates or whatever, and you're like, they're like, but no, you go on your grade book, week 9,
No grades.
100, it's out of 101 points,
Yeah.
In other classes, it's already at like 700 or this. I'm just like, what?
Oh, it's stressful.
Are we still, this is a stupid question, are we still doing stats lab though?
No.
No.
No?
He said no.
Good, because I didn't do shit on that. I'm sorry, I didn't do
Well, I was
anything.
gonna ask him if those grades that we already had in there, if they were gonna be like canceled, or if
I
he's
hope
still
not.
gonna add those, or
Phil's,
what.
oh my god, Phil, I didn't even think
Yeah.
about you. Oh, poor thing.
Yeah.
I
You
would
guys all, like, she texted me, she goes, or emailed me, she's like, Phil. I'm like, Phil is like 10 total hours on this. You have an hour and 2 minutes. So if I'm not gonna do anything, I can't, my mind is like,
The only
Don't
problem I
worry.
had it with
Are our
was
grades in Blackburn
they're
staying?
doing
Yeah.
one problem.
The grades that we have already
there's
achieved in
only,
this class?
there's only like 100, it's only
Okay.
like 100.
Thank
Yeah.
you.
Yeah, we have to kind of figure out.
Well, Taylor, you need to get A's from now.
Yeah, we kind of have to figure out how to blend things, but
Even just Leah. I don't have a B.
but everything you've done is going to count, and it's just a matter then of kind of pro-rating stuff. Okay, and I think the thing that's most new is the fact that we're going to kind of drop my stat lab.
Yes,
Okay.
we like that.
We don't care, but that's great.
Yeah, it's like I said in the video, it's not really of much use to students, and this is just something I've seen from studies, my own experience, your experience. So we'll try to do everything without that. It should cut down. The homework should not take more than an hour and a half max.
Oh my gosh.
Okay,
Well,
max.
compared to what we were doing,
20
that
minutes
is
for Phil.
amazing.
Yeah.
That's good.
20 minutes for Phil.
So we'll see how it goes. And, we're gonna have to tweak things a little bit. And so your feedback's really important. If something's not working, or I can do something to improve it. But I think you're gonna find out a lot better.
It can't get any, it couldn't get any.
It's no.
What did you say about the project?
And the project we'll talk about. I think after we do the midterm probably about 2 classes from now, we'll start to talk about the project. How many people here have access to Skype?
Except for I remember
I have access
stuff.
to that.
Okay. Okay, so Skype.
I mean, I don't have one, but I'm sure I could get one. If it's,
Yeah, Skype's real easy to set up. So
So
here's
there's a little camera.
Yeah.
There you got it.
So here's what I'm going to do. Here's kind of an idea, because I need some mechanism to kind of talk to everyone, and because we were just talking about like a project that Bron's interested in, and these things they take a little bit of time to talk out. So probably at some point, about 2 weeks from now, start thinking about something that you want to do. It doesn't have to be something even related to business. It can just be whatever you find interesting that you can do statistics. Okay, it can be related to your job, but it doesn't have to be. It can be anything.
Can it be
that's
like a
interesting.
hobby?
It
Or
could
a
be-
sport?
Yeah, oh yeah, absolutely. He was talking about like a gaming ranking. People do fantasy sports things, whatever you want. Okay, anything that interests you. That's the important thing. You have to like it. And then probably about 2 weeks from now, maybe I'll make like Skype appointments with people, so we can just do kind of like an online sort of thing and talk it out. And I have a laptop with a tablet, so I can sketch things out and kind of work out a plan. Okay, and you won't get it like immediately. I mean, like, good projects take time to do. So, it may take like 2 or 3 times to think about it. We'll talk about it. You get a little more information, think about it a little bit more. But probably about 3 weeks from now, we'll probably have a pretty firm idea. So, but we'll jump off that bridge when we come to it, okay? Won't worry about it too much. If people really don't want to do a project, if you really want to do a final, I'll write a final for you. It's not a big deal.
Would it be like an open book final?
Take home time.
It'll be open book, but I'll be honest with you. The material at the last end of the course is a lot harder than the first end of the course. This is the tip of the iceberg. I'll be really honest.
we don't have homework tonight either.
I'm going to send out homework tonight. I will send out homework tonight. It'll be about 7 problems roughly,
Oh, that's not bad.
and I'll send you the format and all that sort of stuff, and then you'll just submit it by Saturday night, Saturday 11:59, and then whatever problems you get, each problem will be on a scale from 0 to 5. If you get a 2 or below, then I'll give you another problem like that. But in the meantime, I'll put out a video along with a written solution key so you can see what you did with that problem. And if I have time, I'll actually look at your specific homework and actually make a video for you. Say, okay, you missed this, here's what you need to do.
So is everybody's homework different, or is everybody's homework the same?
Everyone's will be the same, but people will make different mistakes. So if I have time, I'll try to make a video for each person where I go over it individually and then send that to you so you can watch it. And then if you get a 2 or below, you just redo that problem. I'll send you another one like it, and you just get the higher of the 2 scores. So it's kind of like my stat lab in that you get to do things over, but you don't have an infinite number of tries. But hopefully, by giving you the written key, the video key, and then my comments, okay, I'm hoping it's going to give you a lot more support than trying to...
Is it going to be in Blackboard, or?
I'll do everything through Blackboard. Yeah, I'll post everything on Blackboard. So by midnight tonight, I'll send out the homework. Okay, I still have to make it, but... All right. So, feel free to ask questions, though. I know this is new. I don't want anyone... You guys have enough anxiety. This is supposed to make it easier. Like I said, everything's conservative. Everything should make this easier for you. And not easier because I want it to be easier, but easier in the sense that you're not getting as frustrated.
I have a question.
Yeah.
Why did you stay with Saturday night being when it's due if we're not doing it through Stat Lab?
Good question. Because what I want you to be able to do, so suppose, for example, like you do the 7 problems and you miss 3 and 4. Then I want to give you time to redo those. Okay? Does that make sense?
Yeah, I've just always had a rule for myself to take Saturday off completely, no homework. Because I do homework usually Sunday through Friday.
Yeah,
Well,
that's my life too.
Well, if you think about it, you'll have Thursday, Friday, and Saturday to do it.
Okay.
Okay? And if anyone really gets into a bind, I mean, I'm willing to be flexible. This isn't written in stone. What I can do is if I make video solutions for everyone and I send them out individually, then we really don't have to have a time limit.
Okay.
So, and I'm going to try to do that. I'd rather do a video for each of you guys to tell you exactly what you did. So,
I was just used to spending 5 hours
yeah.
on them.
If you're spending, so here's the other thing too.
That's-
But and the same thing applies. If you're spending more than 15 or 20 minutes on any problem, give me a call.
Okay.
Okay? But 2 hours max. Anyone goes beyond 2 hours, I'm going to get really mad at you if you don't call me. Okay?
And another question, is it going to be Excel based?
Yes.
Okay.
Yeah. And even the things that aren't Excel, I'm going to ask you to write it in Excel because there'll be Excel computations in every
That's how
problem.
we're going to upload it.
Yeah,
right?
that's right. You'll download the Excel, and then you'll just
And you'll
send
be
it.
able to view our formulas and stuff too.
Exactly.
Okay.
That's right. I can tell. And that's actually important because, see, what I can't do on my stat lab is, and
See what our work was.
right, and my stat lab actually does everything for you, which I don't want. Okay, I want, and in fact, it's actually worse. My stat lab has you use tables, which is useless when you have Excel, because Excel's exact. Tables are approximate, and they're cumbersome. Who carries around a table? You know, but everyone has access to.
What was that one problem?
Computing.
Like an hour within Excel.
Yeah.
Where we had the mid cap and the high, whatever it was.
Oh, those were so
The
stupid.
tallying.
Yeah, we
Yeah,
had to
those
look. We had a big chart, and we had to go through and individually count
I had to, like,
everything.
match what I
It was
writing
awful.
earlier.
Yeah. No more.
I
of that.
cried that day.
No more of that. Yeah, Brian. Question.
Oh yeah, when do we, or how do we turn it in? Is it through Blackboard or?
Yeah.
Okay.
So what I'll do is I'll send you out the Excel file tonight. I'll email that out to everyone. And if people really do have trouble with the Saturday night deadline, let me know. But we'll assume that you'll just email it back to me Saturday, and then I'll try to do everything Sunday, early Sunday. Email that back so that you can make the changes. Okay.
And then the change. We'll have one attempt to change.
That's right. That's right. But here's the thing: you'll have the written
That's what we do before
solutions,
class.
the videos, yeah, and my comments. So hopefully that's enough. And if you still don't understand, here's the key thing: if after you get my comments and you look at the solution key and you still don't understand, then definitely call me. Then you'll be prepared for the next try. Okay.
So in other words, we should just get it right on the first time, because we'll have all this, and we'll have all the stuff that you're emailing us.
You should, but if you do, the nice thing is, even if you miss it the first time, when you do the redo, then you really should have enough to do the redo. And the highest score is the one I'm going to take. So everyone should do really well on homework.
How much is each homework worth?
I have to look back and.
Depends on.
I
Are
don't.
they all going to be consistent?
It's 25% total, so we're going to have to prorate that. So I don't know how we're going to do that. I mean, if you guys want, we can prorate it so that the beginning before the class is very little, the weight. So maybe we'll make 5% before and 20% afterwards.
Nah.
I mean,
Which
I
is
have
what
a B
kicks
in
us in
here,
the
so
butt.
it's not really gonna.
In the long run, that's what we need to know.
It's up to you. Now I know, like, some people have done really well.
Just so I can
So-
see.
Yeah, so we can we can make it fair. We can prorate it so that it's kind of equal. But we'll see. We'll see. So yeah, so right now we'll just assume we're going to prorate it so it's equal.
Well, I just think we just don't want that work to be for nothing. All that time we spent.
No, I agree. I agree. Yeah, I mean, ideally, unless someone's. Yeah, we should make it equal. We should prorate it equally. Yeah, people are doing pretty good except for like chapter 4 or 5.
Yeah,
Most
chapter
people-
4 was the killer.
Yeah, so that should kill you guys. I think I'll be okay. And we might even make. I think a pretty reasonable rule is that we could maybe drop the 2 lowest homework assignments, something like that, maybe. Okay. So I need to talk to Janet to get the executive approval, but we'll try something like that. Okay.
It just sucks that we have, like 6 weeks left?
Yeah.
Yeah.
But you've got like five homework, so there's still a lot to do. Trust me. Okay, so let's do some.
Now I'm going to put it that way. Thanks for just depressing the girls tonight.
What did you say?
Oh, trust me, we're only like halfway through. Okay, we're only halfway through, so we have a lot to do. Okay, so let's do some computations.
Okay.
Let's go ahead and open up Excel, and let's now figure out what percentile New York City salary is actually in. Okay, so we're going from a data value to a percentile. Okay, so let's pull up Excel. And one thing you can do is you can save your whole Excel sheet. What I do is your whole Excel file. I'm just going to open up a new sheet. I'm going to call this, Excel computations. Whoops. Okay. So here's what we want to do. We want to organize things. Okay. So let's make two sides. We're going to be doing for New York City and Muncie. And I'm going to enter the mean and the standard deviation. This is a pain. Come on. Okay. second, so I'll put, I'm going to put New York City here. Okay, so what was our mean for New York City again? We got to go back and look. That was what? It was 60. Was it 60? Let's see. It's hard for me to toggle back and forth between these two. Let's see.
60K.
Thanks. 60K standard deviation is 10, so we'll put 60 here, 10 here. And for Muncie, it was 45 and 5. Okay. And so now I'm going to put percentile here. Well, I'm going to put X here for my data value. And so the salary, this is going to be the salary for New York City, right? So this will be 75. The salary for Muncie I'm going to do is 59. And I'm going to calculate the percentile. Okay? Okay, so there's everything I need. Okay, so if I'm going to calculate the percentile, right, I need a data value, the mean and standard deviation. So what's my command here going to be? I want the percentile, so I'm going to type norm, what?
Dist.
Norm.dist, good. One way you can tell if you type the right value is you look at the first thing it asks you, okay? If it asks you for a data value, you have the right one, right? This is telling me input a data value, not a percentile. So I'm going to go ahead, I'm going to click here. And then I'm going to click on 60 where the mean is, right? Okay. Comma. Click on the standard deviation, which is 10. And I'm going to click on true. Okay.
Will we ever use false for this?
True. We want true. Now, if you type false, you are going to get something. You'll get the wrong thing. You'll get the probability density function. You'll get the value of that function, but we don't want that. We want the area. We want the percentile. Let me pull this over. Okay, so it should look like that. All right. You don't want to type in the numbers. You don't want to type in 60 and 10. You want to let Excel do all that work for you. Okay. So now you're ready. Just hit enter. Okay. Now, notice something. Excel gives you the percentile in decimal form, okay? So usually we're interested in it as a percentage. So I might want to multiply that by 100. Okay, percentile times 100%. And I might want to round that off to 2 decimal places. Okay. And I'm going to format that entire area because I know I want everything to be about 2 decimal places. So I'm going to.
You see, what did you do to multiply your C5? Like, can you go back?
That guy there? Is that the one?
Yeah.
Okay, I'm just gonna take this guy and I'm gonna multiply him by 100. Let's say whatever's in here, multiply by 100. Now I have that in terms of percentage. Okay. So I know that there's.
The same thing.
Is that good? Everyone's. Okay. So this tells me that I'm doing better than 93% of the people, salary-wise. Okay.
Did you take C5 times A6?
Times 100% for this guy here.
Because of law speed function,
Right.
okay. Because I pressed
So
A6
why
as
didn't
well.
mine work?
Let's see. So we want to take a probability and we just want to make it a percentage. So let's see. So you got that. That looks good. A6. Where's A6 though?
100%.
Oh, because you have this isn't a number. Okay, yeah. So that's a really good point. If you have 100%, this isn't recognized as a number. This is just a string.
Oh, God.
Yeah. And you're lucky you got anything, because usually Excel, if
So
you ask it to do
times
something,
100.
exactly, it's 100. Yeah.
I did
To
that.
sell.
Yeah.
I
So you gotta be careful, yeah. There actually is a command where you can format that as a percentage, I believe, but that's okay. That's all right. Okay, so let's do the same thing with Muncie, because we know Muncie should be a higher percentile, right? We'll do the same thing. Norm.dist. Okay, just kind of click on that. Now my salary, my data value is 59. My mean's 45. Click on that. Standard deviation's 5. And it's still true. It's always going to be true with norm.dist. And notice it gives me 1 because I formatted this to 2 decimal places, okay? So let's increase the number of decimal places here.
It is round.
Exactly. It rounded off to 1 because the number is so large. See, it's so close to 1. And now just multiply that by 100. And there we go. So this person is doing a lot better. Basically, he's doing better than almost everyone, right?
True, right?
What's that?
True.
Yes, true. It's always going to be true for norm.dist. That's right. Here, let me go back and click on this. Yeah. Okay, so let's suppose you go to the folks in New York City now. And you say, hey, I'd love to take that job, but in Muncie, I'm in the 99.73rd percentile. Why don't you give me that same salary in New York City and I'll take the job? Okay, so what income in New York City would be in the 99.73rd percentile? Does that make sense what I'm asking?
Yeah, so an easy way to do that, wouldn't you just take the z-score of the Muncie one and then apply it to the normal distribution of the New York City one?
Right, they're actually now apples and oranges. So what I can do now is I can take this probability. So I'm going to use the fact that now I'm going from a percentile to a data value. I'm going to use norm.int, okay? So here we're going to type what's called comparable. I'm just going to make up a title here. We're going to call this comparable income. This is the income that we'd need in the one city that would put us in the same percentile as the other. So this salary here is going to be the salary in New York City that's in the 99.74th percentile.
You said it's comparable income?
Mm-hmm. So right here, this will be the salary in New York City that's in the same percentile, as Muncie. Okay. Okay, so here I want to use norm.inv. So I'm going to start off, and I'm going to choose norm.inv here. Okay, now what do I want for the probability here? I have a couple of numbers. Do I want these numbers? These numbers? Which one do I
Your
want?
100%.
What's that?
Your 100% line.
I want the really large one, right? Because this is the percentile in New York City that I want to. I'm sorry. This is the percentile in Muncie I want to match in New York City, right? Okay, and I have to be careful. Which one of these am I going to use?
The decimal.
Right. And the way you know that is you see probability. Whenever we do math with probabilities, it's always decimal. Okay. So I'm gonna say, okay, now I want to be in the 99.74th percentile. But I want to do this in the New York City frame. So I'm going to use the mean and the standard deviation for New York City. Okay, so I want to say, okay, what data value in New York City is in the 99.74th percentile? And that's all I have to type in. I don't have to type true or false.
And this is the last question, right?
What's that?
It's NYC salary or Muncie.
And then we're going to do the same for Muncie. That's right. Is this making sense? Everyone's good?
No,
Okay. So let's see.
I'm stuck right here.
Okay. So what we're going to do is we're going to write this now. We'll say okay there. what I need is I need that
So
in
the probability
decimals.
of
So go ahead
Muncie,
and
so then
just
the mean
take
is standard deviation of negative percentage.
Okay, I want that in the same form as that.
Yeah, it seems like it'd be back.
9974,
Alright.
and that's the percentiles probability, right? Okay, now we're going to do this over here, this comparable income.
How did you, I want to get rid of that percent sign.
It's possible. Okay.
Oh, that
hold
makes
on.
sense.
Oops, I screwed that up. Sorry.
It's actually the fourth question on there. Because we're figuring out what NYC salary is the same as Muncie.
So
Or is the
now you
same
have to go back to the formatting.
Okay.
Yeah. So
On to that.
So we choose Muncie's
So-
percentile,
So
but
it's
not
an
NYC's
percentage
percentile.
number.
I know.
This is what it comes out to.
But we have to increase the number of decimals. That's right. Because see, it actually rounded that off.
Oh, I thought you said 2.
I did, but then I didn't realize how close that number was going to be to
well,
one.
that's
Okay.
what I was stuck on.
And so let me say a word real quick. So what Shelley did was kind of cool. She formatted it as a percentage. So what you could do is you can copy this and format it as a percentage, but you can't do math with that percentage. Okay, so we have to put it as a decimal.
But I still didn't get the 99.74.
Let's see.
That's what I was trying to get,
Uh-huh.
and I couldn't.
Yeah,
That's what I'm.
you have it, Matt. 99.74. It's exactly the same. 0.99744. Here, that's good. It's the same value, right? Okay.
Okay.
Yep.
Well.
See, isn't this number right here the same as that?
But how did you get the 99.74?
Okay, so this
It
is
won't change on.
right.
Roll that is.
Okay.
So this is the norm like this. Go back and click on the cell.
It gives me a percent sign though. There's no percent sign up there when you did it.
Right, and that's because you have to be careful when you have to format as a number. So that's why I changed your formatting.
Okay, but
See,
what?
so you don't have the percentage sign anymore.
But that does not say 99.74.
No, it doesn't. That's right. So I changed that to right. So actually, so you can do it here if you want. Yeah. Okay.
So
Like, you can do it here. So you can format yourselves and as a percentage. Okay. So
there is not a percent sign up there. Does anybody else see a percent sign
Right.
behind the 99.74?
Right.
Okay, on mine it does. How do you get rid of that?
okay, easy. Okay, so here's what's going on. So here's the problem she's having. This is a good thing to go through. So she has a percentage, and that's because I formatted it as a percentage. So let me show you real quick. Suppose, for example, I want to express this. Oh, hold on a second. Okay, I want to go back and I want to write this as a percentage. I can click on Format Cells, and notice instead of number, I can click on percentage, right? And if I do that, now it'll put a percentage sign after. Okay? But it actually put too many because when I do it as a percentage, it moves it over 2 decimal places.
Another time.
So I had to take off the 100%, okay?
No, when I do number, this is what comes up. Watch.
Yep.
You see what
Okay? But here's the thing. You don't have to format it as a percentage. You can just multiply by 100. Okay? You'll know there's going
I
to be a
wasn't
percentage.
trying to do a percentage. I'm just trying to get to a decimal. No percent sign behind there. But I don't know how to do that. That's what I'm stuck on.
Norm.in will do it. All you have to do is just I'm sorry, norm.dis will do that.
Yeah.
It'll automatically
That's
give
what-
you
no,
a decimal.
I do.
See, look. You want to show her, Phil?
All she's saying, basically, all you have to do is put this times 100, and then you don't have that percentage. That's what
That's all I did.
that's what you're asking.
That's all I did.
Like you don't
Okay.
have to
Let's just take
when he formats
Take
it.
it out.
That's why he's putting the percentage.
take this out.
Yeah.
I'm gonna start all over again.
Sure.
I know what you're talking about.
Can you show me the formula in
Yeah.
C7?
Let's see.
Okay, and then
Yeah.
did
Okay.
That's not,
the
Yeah, that's what I'm
that's not right.
oh the 59.
Because E here is
And that isn't right. And why that isn't right is because.
Oh, because you have E6.
Hold
Yeah,
on.
it should be C3.
Right.
I want E5. Yeah, I had to make this a thing. Let me change to E5, sorry.
Just change E6 to C3.
Or
So-
E6.
When I go,
E5's right.
Yeah, that's right, I'm sorry.
Where do I go
And
here?
then C3.
Change E6 to C3.
There you go. I was gonna say 'cause I got 80.
Yeah, I want the standard deviation, thanks.
As soon as you want to go up to.
Yeah, when I was probably messing around, I changed that around, sorry.
Okay.
Yeah, yeah.
And we don't put like true or false at the end. We just close it off at the end, right?
That's right, that's right. Norm.inf, it'll look like that. No true or false.
But see, I thought
So this is the percentile in Muncie?
I thought you
It's
changed.
saying
Using-
we
Okay.
have to.
But all
though. We have to
here.
put something.
What's that?
It's telling me I have to.
Did you use dist or in?
We're using, let's see.
Oh shit.
Yeah, norm.inf, right? Right. So remember, when you're going from the data, which is the D, that's this,
And then 100.
okay?
Okay, that's where I was like, why is it not coming out? Okay.
And I used to always screw that up. What you want to do is you want to look at the first thing it asks you.
Just 'cause
If it's asking for a probability,
Oh.
then you did the right thing.
So
INV is looking for an individual number.
No, it's actually doing the inverse. Notice we're going one way or the other. We're either taking a data value or going to a percentile, or percentile to a data value. So it's going in the opposite direction.
Gotcha.
Stands for inverse. There's a method behind the madness, okay?
I sure hope so.
Okay. So don't get too hung up with the percentage. I wouldn't even worry about a percentage rate this minute. We just want the decimal answer. You can always convert it to a percentage. That's not a big
So
deal.
in our homework, we're not gonna have to convert it to a percent.
When you write your conclusion, you want to state it as a percentage. That's
Okay,
right.
so just go ahead and do it. Gotcha.
Right. So this is a percentile as a percentage, percentile as a decimal.
is there any way you could maybe email your phone number again?
Sure, no problem. Yeah, I'll do it. Don't worry. That's no problem.
And actually, do we have your email? I'm not sure.
Yeah,
You should.
email
Yes,
You should.
Yeah.
It's right there.
Oh, okay.
No, that isn't that. That's not it. That's
You
not it.
sent us an
Never
email
mind.
though.
But don't worry, I'll send everything else on it. Don't worry. That's cool. Everything else. Okay, so that's norm.inf. This number, how could I check myself? Should this number be greater than 75 or less than 75? Let's think about it for a second. Right, because it's in a higher percentile now, right? So it's getting pushed out further from the mean. So let's check.
Oh, gotcha. Okay.
Boila, 88. Right, greater than 75. This is the 93rd percentile, so if this is going to be in the 99th percentile, it must be higher. Okay? Is it all good?
No.
Don't get too hung up on that. Just
You have
use.
office hours.
Sure, I mean, you guys can call me anytime. And I can do Skype and we can do office hours. I don't have formal office hours, but it's basically whenever you want, just contact me. More than happy to help. Yeah. But here's the thing. We're going to use norm.inf to get this. That's what we really want. We can always convert it to a percentage. That's easy, right? So we won't get too hung up on that, okay? So this is going to give us the probability as a decimal.
So if we were doing what Muncie salary is in the same percentile as New York City, we would do the norm dot, and if we use the probability of New York City, then the mean and standard deviation of Muncie.
Right.
Gotcha.
So suppose you did something really stupid, and you said to Muncie, well, I want the same salary as what I'd have in New York City, the same percentile. That'd be a bad move, right? But we could go ahead and compute that. So here, this would be the salary in Muncie that would be the same percentile. So this would be the salary in Muncie in the same percentile as New York City. Now that would be a bad move, right? Whoops.
Financially, but what if your situation called for it?
Yeah, if the New York City percentile was higher, yeah, it would be good, but in this case, it'd be a bad move. Okay, so I'm going to start off with norm.inf because I want to go from a percentile. Okay. So I'm going to click on the percentile for New York City. That's the 0.93, okay? That's the probability or the percentile for New York City in decimal form. And I want to find out what the data value in Muncie is for that percentile. So that's my mean and my standard deviation. Okay. And again, I draw your attention to the fact that Excel's like a visual computer. You know, this is this is in green, and this is in like a pink color there. So you can literally compare everything. You can find real quick where everything is. So I want the New York City percentile. I want to compute what the data value is in Muncie. Okay. Let's see. Should it be lower or higher? It should be lower, right? Because it's going to be in a lower percentile. So the value should be moving in. And sure enough, it went from 59 to 52.5.
Can you click on the formula again?
Sure, absolutely. Okay. So I went from the percentile in New York City. I want the data value in the Muncie distribution. Okay. So everyone's got 52.5? Are you getting it?
I'm just watching.
Well, you only learn by doing. You gotta do it. So
Yeah,
let's
but if I'm
finish
doing
that.
it, I miss what you were saying up there. If I'm trying to.
But you won't because I'm making a video. So you can always go back and watch, okay? That's the beauty of having the video. The audio is really good. You'll be able to hear what I'm saying.
Oh, it's taking off what your screen's doing too?
Exactly.
Wow.
That's right. Everything on the screen and then the audio.
Magic.
That's right. So watch what you say. Keep it clean.
What program do you use for that?
It's like Camtasia. I think it's called BB Blackberry or something like that. It's like a low-level form of Camtasia. But it's cheap and it's real easy. Okay, so I want to say norm dot in. No, in. Because I'm going, well, the idea behind the in is I'm going backwards. Instead of going from a data value to a percentile, I'm going the other direction. That's what the in stands for.
Inv is inverse?
It's like the inverse, that's right.
Oh, okay.
Instead of going from a data value to a percentile, I'm going the opposite direction. So you're going to click on the value we put in. You're going to click on that value and then the mean here. Yep. Standard deviation. And there's no true or false. You can just hit enter. And you're all good. Bada bing, bada bang. Excellent. Okay. There we go. So that's all we're going to do with normal distributions for our calculations. Okay? A little bit more, but that's the main thing. Okay, so let's go back to the PowerPoints. Okay, so we did all these. Bing. And I think I'm going to leave this. If we have time, we're going to come back to this. These are good exercises. If I don't have a chance to do these, I'll put the solutions online. Okay. But these are good ones to try. So basically what I'm going to ask you for is I'm going to ask you for the percentiles of these scores now. Okay? Let's see if we have time. If we have time, we'll come back to this. If not, I'll go ahead and I'll post this. So basically I want the percentiles for these scores given this. This is what I know about the SAT. And then we want to do the opposite. I want to know what value, because when you do the SATs, the first thing people look at is the percentile, right? So you might want to know, okay, what is the SAT score for the 90th percentile? Or the, 20th percentile, or for the upper 5th percentile. Okay? But let me go on to one more thing. We should have time to come back to this. I want to do one more thing. Okay, so a big question is, how do we know a data set's normal? We don't have these rules like we had for binomial and Poisson. Okay, so it's a little bit harder. And one of the problems with normal distributions is that people tend to think everything's normally distributed because a lot of things do follow bell-shaped curves, okay? IQ, anything dealing with a physical measurement of a person's body, height, weight, circumference of people's heads, length of your index finger, these things are all normally distributed. So it's very easy to think that everything's normally distributed. But here's the thing. In finance, very few things are normally distributed. Not a lot of things. And here's why. Whenever you're dealing with human performance or compensation, it's extremely rare you get a normal distribution. Okay? People, you hear about this thing called the 95%, right? Have people heard about this? How many people haven't heard about the 95%? Has anyone not heard about 95%? Do you know what it is? Morgan, do you know what 95% is? Does anyone know? Phil? Okay, so there's this huge problem people have. It's a fact that 5% of the world's wealth, 95% of the world's wealth is held by 5% of the people. And so people get really upset about this. This isn't fair. This is wrong. It's a fact of statistics. Okay, and here's why. There was an Italian economist called Vilfred Pareto. He had a beautiful mind. He thought about a lot of things. And one day he was out picking peas. He grew peas. And he noticed that 80% of the peas came from 20% of the plants. And that caught his attention. And he started to wonder, well, is that true for people? And it turns out it is. Okay, so this is a fact of nature, okay? And what he found out, people call this the Pareto principle. So in business, this is a big thing in finance and business. It basically says 80% of the effects are produced by 20% of the people in the population. And so this is you can argue about the disparity, but income's always going to be unequal. This is just a fact of economics, okay? So let me kind of show you where this comes into play. Okay, in commerce, people say that 80% of your sales come from 20% of your clients. Okay, that's one example of Pareto principle. Okay. Performance, and you're going to find this out if you don't know this already. Most of the work's done by a small percentage of people, okay? The more you're in the workforce, the more you'll appreciate this. This is
projects.
Yeah, exactly, you know. It's like 4 people are working on a project, only 1 person's doing something, right? This is almost always true. Compensation. So this is where you really see it a lot. This is an interesting area to do a project. Over 80% of the income is owned by less than 20% of the population. So you can actually look at data. If you go to the World Bank,
It's like tip shares,
what's tip shares?
where the servers do the work, but the hostesses get part of their money for the tips.
Let me think about that. Let me think about that.
We make that for bartending or something.
Uh-huh.
For basically having the service to you.
Uh-huh.
There's a percentage of every sale that is put in a pool and then distributed in the like the busters make $5.50, but that's not minimum wage, so it comes in as that. So the more people that come in is better for the tip share, because every time you're closing out a check, a percent of that check goes into a pool, which is then distributed to.
So how do they determine how the tips are shared? How do they split it up? Statistics.
How much percent do you get?
Hey, that could be your project, Taylor.
Yeah, I can do that. I don't know what the percentage is, but I mean, obviously, if you're there for an hour, you're going to make this, but if you're there for the 5 hours, you're going to make such.
Well, let me ask you a question.
People get different percentages?
Exactly.
Like, do hostesses get different than
Hosts,
bussers?
yeah. Well, at Olive Garden, it's just bussing the bartenders, but.
Oh.
See, that's where we're coming to play.
I'll have to ask.
Yeah. So for example, if you have 2 people working, and say Caitlin's a real hustler, and she does a lot of the tables, and Taylor maybe isn't doing as many, then it'd be unequal sharing. That'd be like a human performance thing. Then that would be what will come in. Okay. And if you actually look at the companies, the countries in the world, basically the richest 20% of the countries own over 20% of the wealth. Okay. So it says communism's never gonna work. I'm sorry. Okay. You know, in principle, this is just how the world is. Things are unequal. Okay. Companies are like that. So, you know, for example, if this is from a paper that a person wrote not too long ago. They looked at 6,000 households. They looked at the distribution of income. That's not normal. I mean, it's not normal in the sense of being a normal distribution, right? It's not symmetric. It definitely has a tail on the right. Okay. So you can see that a lot of people don't earn very much, and a few people earn a whole lot. But if you add up the aggregate wealth, most of it's contained in here. Okay? A whole lot of $1 bills is not the same as a couple $100 bills. That's kind of the moral of the story. So the whole point is that a lot of things in finance are not normally distributed. So we have to make sure that the data is normally distributed. So how do we do that? Well, here's kind of the problem. With discrete, we had these nice rules. For normal, we don't have rules. Okay, so what we have to do is we have to actually look at the data. We need to plot the data. We need to compute some things. And we need to see if the data behaves like a normal distribution. And that's the only way you can know. All right? So, the book gives you some different ways of doing it. There's 3 different levels of testing for normality. Think of these as kind of like fishing nets. Okay? The first is a net that has really big holes. That's going to catch the things that are definitely not normal. Okay? So this first net is where we just plot the data, and we're going to do a few theoretical checks. And the book actually discusses these too. I'm not going to go into all the theoretical checks, only 3. This is like the lowest level. Okay? And we're going to talk about what we're looking for here. The second level is this thing called normal probability plots. We're not going to do that. The book goes into a whole section on that. It's really not very useful, in my opinion. So we're not going to worry about that. The third level is where you actually run really strict tests. So these are very, very, very sensitive to tests. We're not going to do this either, except if you're doing a project. You may have to do this. 3 weeks from now, we're going to cover chi-squared distribution, and I'll show you how to do a test like this, okay? But this is kind of like the gold standard. So we're just going to do this from now. Don't worry about section 3 in the book. It's no problem. It's not really worth it, okay? So we want to focus just on this. Okay, and so let's see what we have to do. First, we're going to plot the data. So we have to make a histogram, okay? And what we're actually looking for is we want to make sure that histogram has a nice bell-shaped curve. Okay, it's symmetric. It has a bell shape. And so the thing that you have to understand, this is the important thing, is that even when the data is normally distributed, if you don't have a lot of data points, it may not look bell-shaped. So the shape of this curve depends very strongly on how many data values. Notice those curves that I give you of the blood pressures and that percentage return at the beginning. Okay, there were over 1,000 people in that blood pressure histogram, right? So that when you start to have a whole lot of people, then a normal distribution looks nice and bell-shaped. Generally, you need at least 30 data points. Okay, to make it look normal. If you have less than 30, it's hard to judge. It's hard to make a really good determination. Okay? So what we're going to do is we're going to look at how to make a histogram. That's why I want to make sure we get this in, because it's easy, but you kind of have to be shown it. Okay? There are a few theoretical checks. So these are actually pretty simple. The first is we want to make sure that the mean, the median, and the mode are all about the same. Right? For normal distribution, these should all be about the same value. These two, this one actually makes sense now. The range should be 6 standard deviations. Okay, first of all, what is the range?
The highest value minus the lowest value.
Right, the highest minus the lowest. It's the entire range of the data, right? Why should it be 6 standard deviations if it's a normal distribution?
3 each way.
Right, we know 3 standard deviations is 99.7, right? Percent of the data. So this should be true. Okay, so this makes sense now. This will not make a lot of sense. Okay, what is the interquartile range, by the way? Did you guys have interquartile range? Yes? No? No? Okay, well, we need to do this then. Okay, so here's what the interquartile range is. First of all, what is the quartile? I just did laundry. I don't have a quarter. It's a quarter, a fourth, right? So a quartile, if I'm thinking in terms of percentiles, is 25%. Okay? So here's what we're saying. I'm just going to draw a normal distribution. And this is going to be the first quartile, otherwise known as the 25th percentile. Okay? So 25% of the values lie below that, right? And now I'm going to look at the third quartile.
So what's the difference between a quartile and a percentile?
A quartile is just a percentile that's in units of 25%. Okay, so you think of a quartile as like a quarter. It's a fourth of a dollar.
Okay.
Okay, so below here is 25%. That's the first quartile. The second quartile is what? That's the median, right? This is the median, because this is now 50%, right? And below here is 75%. That's the third quartile, or the 75th percentile. Okay? The interquartile range is the third quartile minus the first quartile.
So there's not 4 quarters.
Yeah, but the hundredth quartile is the 100%. That's everything.
Okay.
Okay, that's the fourth quartile is everything. So the interquartile range, is just the third quartile minus the first quartile. It's whatever this data value is here, minus that data value here. Why would I care about that? Well, what percentage of people lie in here?
68.
No, this is quartiles, not standard deviations, okay? 50. So this tells me where the middle 50% of the data is. This is a measure of the width, okay? So this tells me where the middle 50% of the data is. In other words, between the third quartile and the first quartile, there's 50% of the values, right? That's the middle 50%. So this is also a measure of the width. Does that make sense, Caitlin? Is that good? No?
If you subtract the third quartile from the first quartile, how is that 50%?
75 minus 25.
Right. This is
Okay, never
exactly
mind.
right. Exactly. Right. Bingo. Right.
I don't know what I was thinking.
It's like
It took me
75
a second to
seconds.
get it
You were
too. I was like,
the
uh-huh.
third
Yeah.
minus the one instead of all 3 of them minus just the one.
Okay.
And what's a little tricky is this is actually a data value. So this is actually a length. This is whatever the data value is for the third quartile minus the first quartile. Between these two values is the 50% of the middle 50% of the data. So this is kind of this is kind of a new way of looking at data. Okay. So what's true about normal distribution is it's unique in that this interquartile range is about 4/3 of the standard deviation. So I can check that. We're going to see how to do that. Okay. These aren't rigorous tests. We're just looking to see for something that's really not normal. Okay. If we're not sure, then we have to go ahead and do more serious tests, which we're not going to worry about right now. Okay, first thing I want to do is I want to make a histogram in Excel. So here's what we're going to do. We're going to have some fun. I'm going to teach you how to generate random numbers. First of all, go to Excel.
You say fun.
Fun, absolutely. This is fun.
Brain.
Yes, absolutely. Okay, let's go to a new tab. Okay, let's go to a third. Hang on. Let's go to a third sheet here. Okay, I'm going to call this X. This can be my data value right here. Okay, what I'm going to do is I'm going to put 50 normal random variables. So here's what I want to do. So I want to create 50 normal random variables from the same distribution. So I'm going to create. Let's do 100 normal random variables. And they're going to come from a normal distribution that has a mean of 100 and a standard deviation of 15. Okay, so I have this normal distribution. I want to generate 100 guys from this distribution. This will come in handy in your project. So here's what we do. I'm going to click here, and I'm going to go to this thing called data. Okay? So you want to click on the Data tab. Then you want to go over to Data Analysis. Does everybody have this icon?
Nope.
I don't have it.
Show detail and hide detail, but they're like blacked out.
Let me check real quick. Nope. Okay, so, and this is something that you're going to want to do anyhow, because you're going to do this on your own computer. We're going to download it. It takes 30 seconds.
Hold on, I lost everything. What did I do? I lost my whole bar up here. I don't know how, what.
View?
Just on that little arrow, I did it to you, but I just exited out and started a new one.
Okay. But I tell you, save it first. Save it first, because you have stuff you want to keep.
Or I
Okay?
can just,
And just open up
That
the
same arrow, just press the
no.
page button.
What you do? Go ahead and follow.
You press the arrow and it collapses it, right? Pull it back up by pressing data, and then at the bottom right, click the little pin.
Do you want to show?
Oh, got it.
You have to play around it. And you got it. You got it. Excellent. Excellent.
I got it.
Okay, so here's what I want you to do. I want you to download data analysis. Here's how you do it. You go up to this file and go to options, I believe. Hold on 1 second. Give me 1 second. Yeah, file options. Okay? And you'll click on this thing called add-ins. You have to do this on your own machine, okay? So this is a good thing to do now. You go to add-ins. Okay? And I'm going to go to Analysis Tool Pack. Everybody with me?
Yeah, mine's a little
I
slow.
was already highlighted.
It's okay. Take your time. Let me know when you're ready, because I don't want to go too fast.
That is analysis toolpack.
Uh-huh. You can click VBA. That's for Visual Basic. Don't worry about that, okay? Okay?
Okay.
You're gonna click Go at the bottom. Okay?
Hold on. Bill's is.
That's okay. I want to make sure everyone's good. Yeah, there's different versions. You gotta play a little bit. Add-ins? Huh?
Let's call it.
Statistics.
Think
Call it deceased 822.
Yep. Click on Go. Yep.
It's not that
Little Go button. Okay. And now it lets you pick. You can go ahead and do all this. It doesn't really matter. We only need this one. Go ahead and click all these, and then click OK. All right.
Uh-oh, cannot access.
Nope, cannot access for multiple reasons. Yep.
Okay. So,
Cannot access.
holy cow. Do they have this set up so that you can't do it?
It's probably blocked.
Yeah, you can't.
We're not allowed to have extra stuff in
But
classes.
mine works.
If it's gonna help
Let's
us,
get
we're
it
not.
on a laptop.
Okay.
Fancy.
What if we just did
Can
the
you
one?
just-
So would it work
Click
on
the
our computers? Just
Yeah,
maybe
it
not
just
the
worked
school's
on his
computers?
laptop.
Yeah. Right.
Oh,
Because
okay.
they have permission.
I just clicked on the one, and it didn't come up. I don't know if it added
What one
it.
do we need to click on?
Girl, I can tell you real quick. Go to
After
go to
analysis tool pack. What do you think?
and it's not. I'm not doing it.
After analysis tool pack. What do you
See,
think?
when I,
Just go.
Let's see real quick.
Yeah, it didn't work. I still don't have it.
and then just the analysis
Yeah.
tool pack, and then I just
Yeah,
clicked
just
on
analysis
that,
toolpack.
but it didn't give me that.
But it's not showing.
I wonder if you have to restart your computer.
Mine didn't do
You didn't give me
Options as
it. Is
analysis
this supposed to
toolpack.
Is yours all gone?
change anything? Because
You're supposed to add the
Yours all
data
go?
analysis.
Just use the company tab.
I opened up the whole new thing.
Oh,
I exited out and it didn't mean to. So
okay. I think mine worked. Didn't come up with any.
drop the mic, walk away.
Yeah. Okay, so here's what I'm going to do real quick. I'm going to make up one and send it to you by email, just real quick, okay? I'll show you how to do it, and then you can do this. You can kind of just mimic this. So random number generation, I want one variable. I want 100 instances of it. I want it from a normal distribution.
You gotta slow down, dude.
But that's okay. It's going to be on the video, okay?
It's going to be in the video.
Okay.
It'll be okay. With a standard deviation of 15, sorry. And I want this to go right here. Okay, I'm going to send this to you right now. Sorry about that. I can't believe you can't do that. That's really...
So we need to get on our email.
Yep. And I'll send this to you right now. We'll call this histogram. Yeah, I'm sorry about that. I've never seen that before. So I don't know what's going on. Okay, let's see real quick. Yeah, so go ahead and get on email, and then I'll send this to you right now. Oh, it's not. Oh, I can't. Oh, I'm not hooked up to the server. Okay.
Are you recording?
Hang on. Man, I can't get this. Okay, I'll tell you what I'm gonna do. I'm gonna do this. I'll tell you what, this will work out better anyhow. Why don't I just do it? I'll show you how to do it. You have the video, and then you guys can do it. So just kind of watch for right now, okay? I'm sorry. I can't believe that you can't do this on the thing, but you can't. Sorry. Okay, so here's what I want to do. Okay, I want to make a histogram. The first thing I'm going to do is I'm going to order the data values from highest to lowest, okay? So what you do is you highlight all of these, and you click on sort. And I'm going to say smallest to largest. And you see now it has them all ordered, okay? It does them automatically. Okay? Now what I'm going to do, the reason why I want to do that is I have to make bins, okay? So I'm going to look at the largest and the smallest. So the smallest is about 65. And I'm going to scroll down to the bottom. And the largest is 134. So I have to go from 65 to 134.
Are you doing approximates, or do you want like the actual decimal?
So here's the trick. Now I have to make these bins. And I want these bins to be nice numbers, okay? In other words, this is going to be a histogram. So I want it to kind of like be in tens or fives, okay? So if I look at this difference right here, right? This is what? This is going to be about 69, right? This difference is about 69 between the highest and the lowest. I need at least 6 standard deviations, right? I need at least six of these blocks. So I'm going to make each of these 10. Okay, so I need to make these bins. I need to make at least 6 bins. Just follow me, okay? So what I'm going to do is I'm going to go over here and I'm going to call this bins. Okay, so the idea is I need at least 6 bins. Okay, so I'm going to start at 60 and I'm going to go up in tens. So I'm going to say 60, 70, 80, 90, 100, 110, 120. And I only have to go up to 140, right? Okay.
More than 6.
That's right. I have to have at least 6, okay? Because
Oh, so you can have more than 6.
you can have more than 6. But I want these to be nice numbers, okay? So these are nice numbers now. The reason why I need at least 6 is because of the empirical rule. I need at least 6 of those bins, okay?
So why would we have more than 6?
You can have more, but you can't have less. If you have less, then the picture's too fuzzy. You don't have enough resolution.
So this is just for Excel. We don't have more than 6 if we draw it by hand.
You should have at least 6. At least 6.
Okay.
I need at least 6 little bins, okay?
So in other words, we're like
What's a
going
bin?
to have more than 6. I don't know.
Is a bin the same as a standard deviation?
No. This is the bin. This is taking all the numbers from 60 to 70. And I'm going to count the number.
So it's an interval.
So how many numbers fall in?
Each bin.
Right.
Okay.
Right. So this is everything up to 60. This is like basically 50 to 60, 60 to 70, 70 to 80. And Excel's going to do this for us, though. I just need to make the bins up here. So I'm going to go over to data. And you just want to follow. Histogram. This is the input range. There's a nice little trick in Excel. If you hit Control-Shift down arrow, it automatically goes to the bottom of the data. So I'm going to hit Control-Shift down arrow. It automatically goes to the bottom.
Why did it anchor it?
I'm not sure. I think this is how it does it.
Okay.
That's a good question. I don't know.
Because if you anchor it, it's not supposed to go down, right?
There's such a thing as right and left anchors, but I'm not sure. I'm not sure why it's doing what it's doing, to be honest. Okay, so now I'm going to go ahead. I'm going to put the histogram bar chart. Whoops. You gotta be careful, it always does that. Let me do this again. Okay, now I'm ready. So now I have to put the histogram someplace. So I'm gonna put it here. Scroll up. That looks good. And that's how my histogram, okay? This is telling me I have 0 below 60. From 60 to 70, I have 1. That's true, right? From 70 to 80, I have 8. Okay? And it's just counting. So these are my bins, okay? This is from 50 to 60, 60 to 70, 70 to 80, etc. Okay? And now I'm just going to plot these, okay? So just kind of go along with this for right now. It'll make sense as you do this. So I'm going to go ahead, I'm going to make a chart. I'll make a scatter plot. And I'm going to convert this to a bar chart. Okay. And that gives me my histogram. Okay. Now, is this from a normal distribution? Well, it is. I mean, I created it this way. But notice it's not exactly symmetric, okay? But it looks kind of symmetric, okay? So this is what a symmetric distribution looks like. It's not perfect, but it looks kind of symmetric. If I had to draw a best fit curve, it would go like this, right? It would look pretty symmetric. Okay? And this will be online, so you can do this. So based on this, I'd say this is pretty normal, okay? So now I want to go ahead and I want to compute a few things with this, okay? So this is how we do the histogram. And now I just want to compute a few things with this. And this is a description of everything I did too. So now I want to check that the mean is the same as the median, is the same as the mode, okay? So how am I going to do that? Well, I'm just going to use Excel, right? I'm going to have Excel compute the average. Excel will compute the median. Okay? So I'll tell you, go ahead and just put some data in and try it. Just make up a quick data set. So in Excel, let's go ahead and do this. We'll say 1, 1, 2, 3. We'll say 1, 2, 2, 3, 3, 3. 4, 4, 4, 4, 4, 5, 5, 5, 6, 6, 7. Okay, so 2 2s, 4 3s, 1, 2, 3, 4, 5 4s, 3 5s, 2 6s, and 1 7. And this should be kind of symmetric, right? Sure. So let's go ahead and compute these and see if these kind of match these conditions. And let me catch up with you here. So I said 1 1, 2 2s, right? Whoops. Whoops. 2 2s. There were 4 3s, right?
Yes. 5 4s.
Thank you.
3 5s. 2 6s and 1 7.
3 5s, 2 6s, and 1 7. Okay. So let's go ahead and compute these statistics, okay? I want to compute the mean, the median, and the mode. So the mean's just going to be the average, right? So I'm going to type in average. Click Control-Shift down and hit Enter. Okay? That's a really nice little feature. I like that. Okay, median, you can do it one of two ways. I'm going to type in median. When you type in median, you can also type in quartiles. You can do the second quartile, but median's easier, right? Same thing, I'm just going to highlight the data, Control-Shift down, Enter. Notice they're about the same. 3.9. We're looking for something that's really far off, okay? Like twice as large or something like that. Those values are pretty close. Now the mode, okay, here we know the mode is 4. But when you do it off a histogram, you're going to actually have to look at the histogram, okay? Yeah?
I got the mean is 4? Is it just because I'm not out as many decimal places as you?
That's right, that's right. So if your thing gets scrunched in, it won't use as many decimal places to round it off. Yep. If I round up, I get 4. And the mode we know is 4 just by looking at it. So this, based on this alone, this looks normal.
What's the difference between their mode functions? There's a mode mult and a mode single.
Yeah, I have to take a look at that. I don't know offhand. But for our purposes, we're always going to have to go off the histogram because the problem is that we're going to have so many values, you're not going to be able to pick out one value. You have to bin them and then pick the bin that has the highest number. Okay, so we're always going to use it. It just turns out this is kind of like a little toy example, right? Okay, so this passes this test. That looks good. Okay, so now what I want to do, the next thing I want to do is I want to look at the width, okay? So I want to compute the range, and I want to see if it's 6 times the standard deviation. Okay, so the next test is I want to take the maximum, the minimum. I want to compute the range from that. Whoops. Then I'm going to compute the standard deviation, and then 6 times the standard deviation. And I'm going to compare the range and 6 times the standard deviation. Okay? So max is easy to get. That's just a command, right? I'm going to say equal max. It comes up right there. Okay, Control Shift down. I know it's 7, but I just want to show you the commands because it won't be as easy in a real data set. The minimum is also min for min. Okay, and do the same thing, Control Shift down. And that should be 1. And then the range is the max minus the min. There's actually a command for that, but I like you to get used to computing it. Okay. Now the standard deviation, you gotta be a little careful. There's 2 standard deviation commands, okay? So let's start typing in STD for standard deviation. This is the one we want. We want the sample standard deviation, stdev.s. I'm gonna click on that. There's not a huge difference, but there can be for small samples. Okay, so it's about 1.5. And now I'm just going to multiply that by 6. Okay. And notice it's a little bit different. Okay? So, you know, this is the range is 6 here, the standard deviation is 9. We might have to worry a little bit about that, okay? That doesn't look good. This should be equal to this, right? But they're not. They're actually pretty far off. So that's kind of worrisome, okay? Okay, last thing, we're going to compute the interquartile range and see if it's 4/3 of standard deviation. Okay, so I'm going to go down here. I'm going to type first. I'm going to put the first quartile. Whoops. Okay, third quartile. And then the interquartile range. And then finally, I'm going to take 4/3 times the standard deviation. And I've already computed the standard deviation, so I don't have to redo that, right? Okay, so now we want to get the quartiles. So we're going to use the command QAR. We're going to start off QUA, sorry. So I'm going to say QUA. Okay. And we're going to click on, we can click on either one. I'll click on this one. Okay. And what I'm going to do is I'm going to highlight the data first. Okay. And then I'm going to type in what quartile. I want the first quartile, right? Notice Excel tells you what to do, right? It says if you want the first quartile, type in 1. So I'm going to go ahead and do that. Okay, so 3 is the first quartile. In other words, 25% of the values are less than 3. Okay? The third quartile, I can just cut and paste that command and change the 1 to 3, right? We'll make life easy on ourselves. So I'm going to cut this and paste it back in, and then go over to here and paste it back in and change that to 3. Okay? Or you can retype it if you want, and that's going to be fine. Okay? So the interquartile range is this minus this. So it's Q3, the third quartile, 5, minus the first. And of course you could do this, but in general this is how you're going to do it, okay? So we're just going to get 2 there. Okay, now I'm going to multiply 4/3 the standard deviation. So I'm going to take the standard deviation, which is here, multiply it by 4, and divide by 3. Okay? And I get about 2 again. Okay? So this is one of these cases where it's a little hard to tell. Okay? The mean, the median, the mode are all 4. This should be equal to this. It is. But this is a little bit off. Okay? So this is where you never get anything perfect. So I'd say this is probably normal, but you may have to do a little more tests. Okay? So I'd say this is probably normal. This is meeting most of the tests. All right, I'll tell you what, we still got some time. We got 10 minutes. We still got time.
The brain's gone.
No. Okay, any questions on this, the 3 tests? We're seeing if the centers or they should be, and then we're doing 2 checks on the width, right? Okay. Okay, with your permission, I'd like to go back and do a few of those percentile problems. It'd be real quick. We can do it on Excel. I think it'll help you a lot in the homework. I think it's 10 minutes well
help with the homework.
Yes, it's just 10 minutes well invested. Okay, so let's go back to the Excel. So here, the PowerPoint. So here's what I want to do. And I don't think there's anything more here really. We're done with that. But I want to go up to here. Yeah, right here. That's what I want. Okay, so let's compute some percentiles of these scores. Okay, these will be quick, but this will help you a lot on the homework. So I'm going to go to Excel, and you have this on the PowerPoint anyhow. I'm going to open up, and you know, by the way, I'm going to save this sheet, and I'll email this out to you guys also. Okay, so if you want to look and see what I did.
Why can't you just go back to sheet 1?
I'm sorry, what's that?
Why can't you just go back to sheet 1?
I like a clear sheet. I like to start calculations on a clear sheet. Everyone's different though. Okay, so I'm going to put my mean here. It's a 515. But anyhow, I'm going to send this whole thing to you guys so you can look it over if you have any questions, especially because the histogram stuff's on here. Okay, so these are the data values, and I want to compute the percentiles. Okay. So the data values were 760, 400, 212. We actually did this. I actually could have used a sheet that we did for the z-scores, right? Yeah, okay, that's all right. Okay, so I'm going to compute the percentiles. So what am I going to use to go from data value to percentile?
Normal distribution.
Norm dist. Okay, norm dist. Put in my x. Put in my mean.
Anchor it.
Exactly. I'm gonna have to anchor that because I don't want to have to do that over and over again. Hit true, and then go back and I'm going to anchor. I don't think there's a command to easily anchor. I don't know if there's a shortcut command to anchor or not. I don't think there is. Okay, boop. And we're done. Okay. Everybody's good? Where's your Excel sheet?
I exited it out so I can focus just like for her thing.
Okay, okay, all right.
I
Okay.
didn't Excel. I had my computer was frozen, so I had to log out.
One thing I'll tell you real quick, this is important. When you're working with Excel, never stop in the middle of a command. Excel will freeze and you'll have to force shut and you'll lose everything. So it's always a good idea to be saving. And I should have. I didn't do it myself, but you should always save in between, right? Okay, so there's my percentile. I'm just going to drag that guy down. Okay. If I want to, I can format this now as a percentage, okay? It's not a bad idea. If I'm not going to do any more work with these numbers, okay, I can format them as a percentage. Let me show you how to do that. Let's highlight them all. I'm going to click on Format.
Can't you just click that % button underneath General?
Yeah, you can. I always go to Format, but that's right. There's more than one way to do it. Yeah. And that's going to give me as a percentage if I want to do that, okay? I can't do math with those now. So if I want to do math later on, I don't want to do this. If I'm just computing this as the final result. Okay, so we can look at this. This kind of makes sense if you think about what this is doing here. Okay, last thing I want to do is I want to go backwards now. I want to look at a few percentiles, the 90th, the 20th, and the upper 5th percentile. Okay, so if we go back to the sheet here, the 90th, the 20th, and the upper 5th, and I can do these all in 4 minutes. Okay. Percentile. See, this is how little time it's going to take you to do the homework, though. So this has to be in a decimal, right? 20th. What is the upper 5th percentile? Is that 0.05? What does that mean? What does it mean to be in the upper 5th percentile?
95? Is it 95?
Upper 5th percentile means that only 5 people sit above you, which is the same as a 95th percentile, right? So there's 2 percentiles. There's the lower percentile and there's the upper percentile. When we don't say which one it is, by default, it's always the lower percentile. But the upper 5th percentile is the lower 95th percentile. Okay, so it's 0.95. And watch how quick this is. This is a data value. What am I going to use here? Norm.dist. Is that right?
Or the individual, or in something.
Im, that's right. There's only 2. They show up the first, the second. Okay, so it's this, comma, the mean, comma, standard deviation, and I got to anchor. Dink. But you can see how quick these go. It doesn't take a long time to do these. Okay, and I'm going to pull these down. And one thing I want you to get in the habit of doing is rounding off things, okay? And there's my final answers.
So I got 760, 400, and 212.
What do you have for percentile? Let's see. 9.2. Can you click on the cell that you have? 1.m, B1, B2.
What's her sigma?
What's this, D5? D5's up here, though. You want that guy?
Oh,
Because we're doing those guys. That's it. Yep. So I'll send you the video. I'll send you the Excel file. I'll also post the PowerPoint, although that you have a copy of that, okay? So you're all set. And we're under 8:50. I told you how little time it takes, all right? Okay, looks good. I'll send you guys out the homework. If you have any questions, keep me in the loop. No question too stupid or whatever to
How
ask.
do we view this video recording or whatever?
It'll be as a WAV file. Actually, Blackboard already has the building capability, so if you have Flash,
Is it what you posted for the video?
But it's just
about
going to be
the
on like
grades?
announcements
Yeah.
or something?
yeah, it's the same video. If you can watch the video for the announcements, you're perfectly good. Okay, if people have trouble, I can save it as different things, but I think it just saves it as an MP3, I think. All right. Okay, thanks a lot. I'll see you next Wednesday. All right, I gotta get out of here. Power to render, and I'm gonna do like administrative stuff. So if people want to stay after and work, feel perfectly free. I know 3 hours is a long time, okay? But you can always feel free to talk to me.
$1 pictures tonight? $4.
All right. Right. So,
If there's any way I can get those early, that'd be great. I don't know if that's possible.
the thing is, you can get them early, but I'm wondering what good it will do. That's the problem. I'm wondering, like,
Well, I figured I'd do all of it this week. You know what I mean?
what is all of it, though?
I need this homework that you're sending out tonight, then following homework.
Yeah.
I need two of it. I need 3 homeworks and the midterm, basically. And I'm sure you don't have them done, right?
The problem is, it isn't so hard getting the homeworks, actually. It don't take that long to make. The problem is, though, I'm really worried about, like, ability to be able to really do them. I wonder. Do me the following, just so I can keep myself straight. Send me an email with the dates that you're going to be out, okay? And then, I'll kind of work backwards, and we'll work something out. I wouldn't worry, okay? We'll work something out, but just, yeah. So, because you're going to miss what? You're going to miss.
I'm just going to miss one class.
Oh, okay.
But I'll be here next week.
Okay.
But I'm leaving at 5 in the morning on Thursday morning.
Right.
So right after class, I'm going home, getting ready, and then our flight leaves.
Okay.
That morning.
And then you're not going to be doing anything.
Right. I will be gone until. I'll be gone
You'll miss the next class, right?
Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday.
Right.
And I won't get back into Muncie until Sunday night.
Okay.
So that's why it's like if you send out an assignment next week on Wednesday, I won't see it. Like I will have maybe an hour to do it tops. You know what I'm saying?
Yeah.
Tops.
Yeah.
And that's saying a lot. And then.
So let me ask you a question. So here's what I'd like to do. I don't know if this works for you or not. Because this next section we're doing is actually the hardest of any section we're gonna do.
Perfect timing.
And that's okay. It's not a big deal, but
Sure.
it's kind of like to kind of be forewarned and this to kind of build like a strategy. So what I'm thinking is this: why don't you come to class next Wednesday? Really concentrate on the lecture. I'll send you out the homework afterwards. You're not going to get to it till later, which is okay.
Right.
Because you're actually going to be two homeworks behind, okay? You should be able to do, although you're going to have a lag, because you're going to go 7 days without doing statistics, and so
Sure.
it happens to everyone. It happened to me, okay? So you'll have to go back and go back over it, but you can do the homework from 2 weeks back. What I'd like to do, if it's possible, is to meet with you between when you get back and Wednesday's class and go through the lecture. Although I'm going to post the video too, and I'll post the homework. But I think if we kind of work together, we could probably get it done a little faster, and I can kind of step you through the homework.
Sure.
Okay? So why don't we do that? So don't worry about, because I think trying to trying to work ahead is going to be hard to do.
Okay.
I think it's not going to work very well.
Okay. So just get what you send out. I'll get done that, and then just wait on the next 2 homeworks.
So when you get back,
And then
hit
I'll
the sampling
catch up.
distribution. I would go back over the lecture, hit the sampling, which is what we're going to do next time. Hit the sampling distribution, and try to see me before. Could you meet me before next class? Even though I am going to post a lecture, would you be able to meet me before?
My wife doesn't get off until 5, so I'll have my son, you know what I mean? That's the only issue I have before class.
Okay.
I can get here 5,
See, here's the thing, Phil.
20 minutes before, that's it.
See, here's the thing. I don't really worry about, there's 2 things important, okay? First of all is that the stuff doesn't really build on itself that much,
Right.
okay? It does a little bit. The one that you're going to miss actually does build on it a little bit, but it's not that bad. And you can watch the videos, and you can play catch up throughout the week. I think you're good enough that you could do 2 homework sets
Sure.
within a period of time, okay?
Yeah.
So I wouldn't worry about it. We'll just
Okay.
keep on top of it.
Yeah, I just wanted to make sure I didn't want to, miss an assignment and then not
No.
make it up. You know what I mean? That was my only
Don't worry.
concern. And then with the midterm, you're going to pass it out, I believe. You're passing it out the week that I'm actually missing. It's not next week. It'll be the following week, correct?
Yes, that's right. It's
So
not next week.
I won't receive the midterm because I won't be in class. That's the one day I'll miss class.
But I'll send it out. I'll actually send
You'll
it out. It'll be written out, yeah.
And then I'll get back that Sunday. I'll have Monday. Well, when's the midterm due?
It's due the next class, but again, we can
Okay.
we can work around that, okay?
I think that I should be able to get it done though on Monday and Tuesday. So I'm not Monday, Tuesday, and Wednesday during the day. I'm actually not concerned about that as long as you're sending it out. I still have Monday, Tuesday, and Wednesday. I'm pretty comfortable enough that I can get it done.
You can definitely play catch up. It's not a concern.
Okay.
And if you want to, we can even we can work on Skype if you want to do stuff. If you have questions or whatever.
Sure.
Most of the stuff is just kind of like catching on. It's kind of like the Z-score. Like once you see it, it's like, oh, I got it.
Right.
And then they're all the same problem. Okay.
No, and I know. I just wanted to make sure that you were okay with me missing the date that it's due and then playing catch up when I get back.
Yeah, meeting one day a week really is incredibly restrictive.
Right.
Yeah, there's so many things I can't do. So, I can totally work. We have a small class. I'm really flexible.
Sure.
So,
Okay.
and I don't worry about you. I know you're not going to lag behind. I just want to make sure that if you need help, just
Sure.
know that you can come to me. We can work whenever you want. We'll get you caught up. Alrighty?
Yep. Thank
Okay.
you. I appreciate it.
No, no
Do you know how to print from these in color? If we're able to.
What happens when you? Let's see.
I just printed it off and it was black and white, so I know how to not technological savvy, so. And there's not like a print preview, but I go to print settings, couldn't really find it, so.
And sometimes they don't. Sometimes it's really dependent on the printer. If the printer is not a color printer,
Mm-hmm.
I don't see anything obvious. Page set. I don't see anything. Yeah, I don't see anything ahead.
She's out there, but she doesn't look like she's.
Alright. So things are kind of making sense. It's not too bad.
It's just hard because it's just late,
I know.
all this. She tried, and I really like her,